Check, check. 1, 2, 3, 4.
Whoa, it's bright up here. All right, good morning, everyone. Welcome to the 2022 PACI QA/QC breakout session. Our first speaker is going to be Tate Salih and Robert Simonis. Robert Simonis is a graduate of UK's Engineering School at the University of Kentucky, on the University of Kentucky Scholarship Program. Received his bachelor's degree in civil engineering and mining engineering. Robert has been with KYTC almost continuously since 1984. He now serves as the asphalt branch manager. Tate Salih received his master's degree in civil engineering from UK in 2015. He began his career with the Transportation Cabinet in August of 2015 as District 5 Materials Engineer. He worked there until transferring to the Division of Materials Asphalt section. So please welcome our partners from KYTC, Robert and Tate.
Good morning. How you doing? I think Robert was going to tell a few jokes, but he told me to go ahead and start this. So I've been tasked with updating you all on specifications and what we're doing with performance testing. This light's pretty violent. Items of discussion, I'll talk about a little bit about the last 2 years, how that's affected the Mix Design Lab. Personnel updates within central office, some liquid asphalt items, and then really the meat of the presentation is about performance testing. Hamburg and Ideal CT, future specifications, addressing concerns raised by PACI, and then talk about moving forward. So, first up is just how COVID kind of affected our industry. It's the last 5 years of mix designs approved at central office, and you can see 2020 was about half of what we typically do. A little bit of just mix history for last year. We usually do this every year. It's not that interesting, but 756 mix designs through central office, 668 were class 3, 65 class 4s. Did some drainage blankets. There's probably more microsurfacing than that, but that's all I had on the inventory. And then almost 50 number 4 mixes. And typically we see mostly references, so 595 approvals were references. Personnel updates. So Robert, still the branch manager. Brian Young, in the last 2 years, has been promoted to the liquid asphalt section supervisor. So any liquid asphalt concerns would go to Brian. Under his lab is Alex Simonis and Daryl Young. I, as of January 1st, 2021, am the asphalt mixtures testing section supervisor. And in my lab, there's Billy Davis, Jake Campbell, and Chris Cooper. And then our 3 asphalt field guys are the same. Andrew is districts 3, 4, 10, and 11. Mark Paul, 1, 2, 9, and 12. And Kevin Gilbert, 5, 6, 7, and 8. Just a couple liquid asphalt items. I'm not too familiar with these. It's just, if you have questions, you can ask Brian. But we did update section 806 of the spec. It will come out through a supplemental. It's not out yet, but it is coming. They updated M332 for the PAV DSR, just certain requirements. It's very technical, so I won't talk through it. But concerning non-tracking tax, we do have an update to special note for a seasonal limitation. This is a temporary spec, probably, but it's October 1st through May 15th. prohibits the use of non-track tack. We are forming a committee to develop a bond stress and strength specification, sort of a performance spec for tack coats. And once we have that, that seasonal limitation probably will go away, or change at least. So let's talk about the meat of the presentation. Performance specs. We'll start with stability, so that's the less controversial. It's not the primary concern, but rutting balances cracking performance. So I guess the third item down there is the Hamburg. Doesn't seem feasible moving forward for production. We're going to have it in mix design always, so you'll need a device or a machine to run the Hamburgs for mix design approvals. But Kentucky really needs to shift their field testing to something more practical. So ideal RT, sort of the hot water tensile strength test. There's different ones out there, but we will probably be shifting focus this year going forward in the field, just collecting data and trying to develop a field spec. So we've been running Hamburgs at central office since 2018. For a long time, it was just me doing it. So all of those runs were just saved on the computer and not put into Mixpack or AMOL and uploaded into Site Manager. But since I've acquired some people in my lab, we have completed putting all that data into AMOLs and Mixpacks. So if you're a contractor and you want to know how your mix has been performing in the field, if you don't have a Hamburg, I can provide that information. Just ask for it. So we began meeting July of 2021 on mix design approval specs. Like I said, Hamburg's less controversial, so we settled pretty quickly on a specification for mix design approval. I want to reiterate that the specification we've developed so far is for 1/2 inch and 3/8 surfaces with 64-22 only. Parameters of the test: 1/2 inch maximum rut depth and a water temp of 50 degrees C. We do a 30-minute precondition. These requirements in this table is based on the average of the left and right side. Every once in a while, you'll have a spread. Both sides won't agree with each other, so that's why we're taking the average. But to get a mix design approval, you will have to meet these minimum requirements. So for Class 2, 7,500 passes, you have to have at least 7,500 passes before you reach 1/2 inch of rut depth. And then Class 3 and 4, it's 10,000. The final bullet point, we kind of all agreed as well in these meetings that if 76 is in the mix, 20,000 passes would be the requirement for all classes. But we don't have a 76 spec yet, so that's just for future knowledge. All right, performance specification durability, so cracking performance. Here's a little timeline of our efforts. So 2017, we started something called the Durability Task Force, which sounds important. It was because of the primary concern of cracking in our state. We have felt that superpay volumetrics don't tell the whole story, so there's a need for performance testing in our state. 2018, we selected Ideal CT as the evaluative test because of it's cheap, it's easy to run, you get a fast result, and then there's a low coefficient of variance, low variability, and it seems to be fairly repeatable, even though it might not seem that way. I'll talk about that in a little bit. 2019, July 2019, KYTC put out a special note for experimental testing. This was to collect data on our mixes. So based on the tonnage of the job, you would have these on your contract, and then we would run the crack test every 1,000 tons, and the rut test every lot, 4,000 tons. 2020, Kentucky changed that special note. So the first draft, there was no curing in the field, and we were seeing mixed design ideal CTs of like 80 to 120, and then that would translate in the field to 500 or 600, and they don't really speak to each other. So in 2020, we updated the special note to include a 2-hour cure in the field to try to bring those numbers similar to each other. Moving forward, I think it's important to think of the fact that mixed design and plant mix are two different things. You know, you're weighing up to 1/10 of a gram in the lab. In the field, you're running it through a plant. So there will always be separate requirements, but they should speak to each other. There should be some correlation. Have I done that analysis yet? No, we haven't started that yet. Mixed design to plant mix. We were just trying to roll out a mixed design spec first, so. Balanced performance-based design pitfall. It's only as strong as the correlation to field performance. So no matter what efforts we do in the lab and we come up with a specification, if it doesn't translate to the field, then we're kind of wasting our time. So we're hoping that it does, but it takes time to realize and measure. So we began this in July 2019, and we started getting ideal CTs, and let's say we get 150, and we say that's really good, but we don't really know if it's really good because you can't measure cracking in the field. So what was our solution? We decided to take historical mixes that we did have maintenance data for, so we could tell if it was doing well in the field, and recreate those in the lab to run ideal CT and Hamburg on those mixes. It's not a perfect science. Obviously, if you have a mix that's 15 years old and it does well 15 years ago, moving forward, we're not running the same material, but we tried to do it as best as we could. We used, the same aggregate source, the same binder source, the same mix design, but we do realize that it's not a perfect science. This produced a lot of data, so we contracted with Kentucky Transportation Center to help us out in those data analysis and support efforts. This is on a Zoom call with David. He was deep in thought at this moment. So our procedure, with KTC, we would merge Division of Materials mixed design inventories with Division of Maintenance pavement ratings. We grouped designs from 2007 to 2019 by plant, and we identified similar designs based on their gradation, their asphalt content, their wrap content, different volumetric factors, and we determined which ones were similar to each other. We then matched that with the maintenance ratings so that we could attempt to marry laboratory performance with months in the good condition in the field. We selected 30 mixed designs to capture a thorough state representation of available materials and designs. And then, like I said, we made CTs and Hamburgs according to the governing specifications. So this comes from the KTC presentation we put together in July. So many of you have seen this before, but our current condition in Kentucky was an average pavement transitions from the good to fair category, according to the maintenance rating, in 32 months, an average of 32 months. Second bullet point, of the 30 mixes that we made, 28 were from different plants and 18 different producers. So we spread it across the state. We hit all areas of the state. Purpose was to attempt to solve the correlation issue to field performance. The purpose of that study is not to compare pre-2019 and post-29 mixes. So yes, we made specification changes in 2017 and 2019, and we've been running ideal CTs on them, but we can't know the effects of those changes. So the purpose wasn't to compare the old mixes with the new. We don't know the effects of the new yet. We can't compare them. This graph is just a cumulative distribution of pavement age according to plant average. So basically, if you go to the 50% on the y-axis and you go over, it's 32 months. That's all that graph's telling you. So. Second slide from that presentation, sort of the result of our 30 mix design in-house study. Again, this is 64 minus 22, half-inch 3/8 surfaces only. So based on data analysis, we developed a predictive equation to try to, if you plug in a C2 value, it spits out a pavement age or length in the good condition. So they came up with this table that you see. Remember that we were at an average of 32 months. So based on that equation, there's a lower value, there's an upper value, and there's a predicted value with an 85% confidence level. So for 36 months, we say that if you get a 126 in the middle of the average, that would be equivalent to 36 months. Now, the low end could potentially also produce 36 months. So 77 could also produce that result. So if you go down the table, the lower limits, 77, which is basically 75, 100, 115, and 125. And we were just trying to project out pavement age. So up to 6 years is 72 months. The bullet point there, the industry average for ideal CT is currently at 110, approximately, for these types of mixes, the surface mixes. So that's something to think about. The graph on the right is the green bar is plant averages across the state. So that's contractor submitted data. And then the blue line is the 30 mix design in-house study. So we were trying to follow the same trend. It does pretty well. If you notice, the green line is higher, and I think that's attributed to what you all talk about in our changes since 2019. So dropping to 65 gyrations, 3.5 target air voids. That sort of reflects, that's why that line is farther to the right. That's why those results are slightly higher. But they do generally follow the same trend. So the evolution of our durability spec. So again, we met in July 2021. KYTC started with, we threw a number out there. So we said 125 minimum for mix design approvals for PG 64 minus 22. Yes, if you look at the table, that is the largest minimum value. So we started big and then knew that number would be knocked down a little bit. So September 2021, we heard from industry about their concerns over that number. So as a compromise or a different approach, we pitched a 3-tiered specification based on traffic class. So class 2, 3, and 4 would have different requirements to accommodate contractors who have materials that they struggle with in the state. November 2021, so I thought at that point we were done, we had agreed on something. But November 2021, the State Highway Engineer Office raised concerns with us internally about the impact that this would have on Class 2 mixtures. So Class 2 mixes are 80% of our contracts. So they didn't want to start too low and abandon what we had accomplished with our laboratory study. So we went back with raising it to 110 for 2, 3, and Class 2 and 3, and then 125 for Class 4. For the remainder of 2021 and the beginning of this year, internal discussions continued as well as meetings with industry, and I think, I'm pretty confident a decision has been made. So, specification, that will come out in a letting. I can't tell you what letting. I've drafted it, but I don't know when that will be approved. I'm told it's supposed to be approved as soon as possible. But for Class 2 and 3, the minimum ideal CT for mix design approval is 95. And then Class 4, which is kind of a fake spec because we don't really have a Class 4 with 64 minus 22, is 125. So that update then requires updates of other specifications. So as I said, there will be a supplemental to the spec book. This changes Kentucky Method 64-450. That's our KYCT specification, basically the ideal CT spec. This affects Kentucky Method 64-421, which is getting your mix designs approved. And then it will also affect the special note for experimental performance testing. With that thought, or with that idea, the 95, we were told by the State Highway Engineer's Office that a joint memo will be released with the supplemental requiring increase of that requirement, 95 to 110, in 1 year from whenever the supplemental is approved. So in 1 year's time, whenever the supplemental is printed, Class 2s and 3s will then become 110. This gets you all more time to be familiar with your mix, to find ways to meet that specification. This is the update to the spec book, or this will be in the form of a supplemental, but it looks like the specification. So mixture performance verification for all 1/2 inch and 3/8 inch nominal surface mixtures with PG 64 minus 22, ensure the following limits are met or exceeded to obtain approval. So it's those two tables I've shown put together. Class 2 is 7,500 passes for Hamburg and a 95 ideal CT. Class 3, 10,000 passes, 95 ideal CT. Class 4, 10,000 passes, 125. The footnote, if you can't read it in the back, it just says, mixture rutting resistance shall meet the above number of passes for a critical rut depth of 1/2 inch. So same thing we've been running for 2 years, 3 years now, almost. And again, it's the average of the left and right side, the pass level. And then the second footnote says, test the ideal of the KYCT in accordance with our Kentucky method. So, the Kentucky method. I think maybe there was some ambiguity about how many specimens to make in different parts. Maybe there were different numbers, but I believe I've updated it correctly. So for a mixed design approval, you should make 6 specimens according to specification. So a 4-hour cure, a 4-hour uncovered cure. Under no circumstances shall the mixture be covered in the oven during a 4-hour conditioning period. KYTC feels that it's counterproductive to mixture absorption and binder aging. R30 specifies conditioning in a forced draft oven, so covering is counterproductive to that process. But we've now stated in the method to uncover your pans when you're conditioning. I've also added a section in the Kentucky method for statistical outliers. So this concern of having numbers all over the place, having a really low number when all the other numbers are good, or having a really high number when all the other numbers are down here, we've addressed that. So results outside of a 90% statistical confidence level will not be considered in an average. I won't go through statistics, but basically, based on the average and the standard deviation, You can determine what's out of the middle 90%, and those numbers will be kicked out when you're calculating your average. So that's kind of the reason for having 6 specimens. The more the merrier, in case you do have a flyer somewhere. It doesn't affect you too bad. Because if you're taking the average of 2 numbers versus the average of 5 numbers, you probably want 5 numbers. Uh, 421 updates. So, for new Class 2 and 3 designs, you shall meet the proposed minimum limits. A certified KYTC person shall witness passing result in person in some capacity. I just put in some capacity, meaning we have 12 districts. If the DME in District 8 approves a mix for 9 or 10, or there obviously has to be good communication there, and I will work through that with our DMEs, but you don't need to, District 12 doesn't need to be there for all the 12 approvals and 11, and you can approve for other districts, basically. If the districts aren't available for this process, you can call central office. We have 3 field people. There are 4 people in my lab, people in liquid asphalt. We have the personnel to complete this task. But for the initial approval, we would like to witness a passing test. For new Class 4 designs, shall be made so I make them at central office and verify those results in my lab, just as I do TSRs. So you run your test. If you don't make it, you're allowed a single retest for unsuccessful demonstrations. If the retest is unsuccessful, then there will be adjustments to your JMF. So initial approval, witnessed by KYTC. You can then freely reference that design throughout the year, just as you can now. Performance shall be re-verified each year. So we'll begin this process again the following year. You may reference up and down one mixture class, just as you can now, but you must meet the performance limits and the design requirements, meaning consensus properties of the class that's above or below. So right now it's 95 for 2 and 3, 125 for 4, and then 7,500. So really it's the Hamburg that this kind of affects. If you're referencing a Class 2 to a 3, you have to meet 7,500 passes on a Class 2. When you get to a Class 3, you have to meet 10,000 passes. So if you're referencing up, you got to meet that 10,000 pass limit, minimum. The final specification it affects is the special note for experimental KYCT and Hamburg testing. So it's still going to be required on applicable contracts. We still need that field data. Again, mixed design, plant mix, 2 different things. We need as much data as we can to correlate the 2 in some way. No covering the samples in the oven. I've updated, or I don't think I updated, but just a reminder, you can fabricate 3 to 6 in the field as best you can per sublot. If you miss a sublot, that's fine. This is information. But try to make 3 to 6. And then fabricate 2 to 4 Hamburg specimens per lot. So, industry concerns. I've listed 3 concerns that we've primarily heard. The first being ideal CT repeatability. Second, that the ideal CT is it's an index test, it's not a predictive test. And then the third concern being many contractors cannot meet the specification. So, interestingly enough, I think last week maybe Alan, the director of materials, he sent our lab a FHWA publication called Index-Based Tests for Performance Engineered Mixture Designs for Asphalt Pavements. And they were comparing tests, performance tests, basically. So they had a section about repeatability of all the tests, how they would categorize them. This is based on a level of coefficient of variation, so how variable your data is. Type A's, or level A's, I think maybe the report says, are less than 10% on the COV, the coefficient of variance. A type B is the mid-level, it's 10 to 25%. Type C is greater than 25%. Ideal CT is categorized as a type B, so it's in the middle. And there was no cracking test, durability cracking test, categorized as a type A. So it's right up there with all the other tests. And this included 8 different tests. So a little bit about Kentucky's experience with repeatability. I just put 3 scenarios on there. We have a lot of data, so we can provide plenty of examples. But the most variable experience is the co-op program. So for the last 2 years, we have required ideal CT testing on our co-op mix instead of doing pills and gravities like we usually do. 2021 COV average, 31.5%. 2022 COV average, 24.6%. So that would be the edge of level B into level C, or the worst you can do. Now, why is this? So I don't think my instructions for the co-op are written that well, because people do all kinds of curing and conditioning, and when they run the test. So there's a lot of variability of that aspect. There's also variability of, there's different machines throughout the state, which I'll talk about a little bit. Different users, so more than one technician might work on a co-op sample. So there's a lot of variability built into the co-op program. The second example are single laboratory experiments. So it's not pulling from the entirety of the state. First one I'll mention is bluegrass testing. They did a round-robin study recently, and their coefficient of variation was very low, 9%. So I don't know how many people made the specimens. There were quite a bit, maybe 38 specimens made, if I can remember correctly. So I don't know how many technicians were involved, but they were at least all from the same environment using the same equipment. So it's very low, 9%. I think that's, the level A, the best you can do as far as variability. The in-house study that we did with the 30 mix designs, so making 6 CTs and 4 Hamburgs for 30 mixes, 28 plant locations, 18 producers, that produced a variation of 15.9%. So in that middle level, which is where the ideal CT is categorized. That work was done by me and Brian Young. And without Brian, I couldn't have done this study, so I want to acknowledge that and thank him very much. But it was 2 users at least. I don't do the same things that he does, and he doesn't do the same things as I do. So that could be a little bit why it's higher. He was also kind of learning the mix design process. I mean, he did very well. But so different levels of experience, I guess, is built into that. So that's why we're at 15.9%, or in that middle category. Could be why, I don't know exactly why. But the third example is the validator. So April of 2021, maybe, I can't remember. But TTI, Texas Transportation Institute, the entity that created the ideal CT test, they sent us a validator device that we used for a couple weeks. So we didn't have it very long. I wish we could have used it more. But on top of everything else we were doing, we did get out to 5 different contractor labs. Basically, this device, it's a machine, so it's more perfect than a human. You put it in a test press, and it's supposed to produce the same curve every time. And that is machine to machine. So Pine, Instratech, TestQuip, all the machines we have in the state, it would produce a similar curve. So in 5 laboratories, It's not that many, but that's all I could do at the time. We had a variability of 2.8%. So multiple users, single lab, down to a machine, the test does become more repeatable. A little more on this. So the graph is the ideal CT curve of the validator. So that was, I tested mainly Pine devices in different contractor labs, but there was one auto SCB in that curve. This slide pretty much says what I already said, but just to reiterate, co-op results are most variable due to variable conditioning times and procedures, multiple labs, different test presses. Single laboratory experiments, same lab fabricated all specimens, multiple technicians within the same lab. Validator eliminates human error during fabrication, used on different test presses. Second concern, ideal CT is not a predictive test, it's an index test. There was also some discussion of this in that FHWA publication. There's a field validation section. So level A, one or more studies have been conducted using available local materials. So do we categorize as A, you have to have one or more studies using local materials that correlated lab performance to field performance. Level B, some national or regional research has been conducted but did not use local materials. Level C, no or very limited national research has been conducted. And then to apply the test, a level A test could be used in a mechanistic-oriented parameter or a predictive laboratory performance model. Level C can only result in an index parameter, so it's only an index test. Ideal CT is currently categorized as a type B. Its predictive ability or purely index test categorization is not yet proven. It was an ASTM since 2019, so it's a new test, and there's that issue of it's not old enough to know how it translates to the field. There are some accelerated efforts, but just a DOT assessing their mixes for ideal CT in the lab versus the field, it's not old enough yet. The test is too new. So KYTC's efforts on that concern, we began experimental testing in July of 2019. Division of Maintenance tells me they're able to measure some sort of field performance at beginning approximately at the 3-year mark. So July 2022 is the three-year mark for these 2019 mixes. So hopefully later this year, we will begin seeing some sort of correlation. That's if cracking exists. It might be next year. It's just the 3-year mark is the beginning period to see those results. So that concern is it's not appropriate right now to determine if the ideal CT is a predictive or an index test because we haven't had enough time. The final concern is multiple contractors cannot meet the ideal CT minimums. This is due to local materials being problematic with the test. We've heard the mixed price will only increase to meet KYTC needs. We've heard specifications should be regional to accommodate variable resources, and that other states have lower requirements. This graph is produced from the Kentucky Transportation Center. It is a collection of contractor-submitted data. So I've blocked out the contractors, but this is basically where contractors are at with their mixes. The green line is at the 110 level, it's not the 95 level, but you can see there are some lower contractors in the state and then some that have no problem with current thresholds. So to understand this issue a little better, with the help of KTC, they've done a lot of work for us, and I greatly appreciate it. KTC provided several observations and characteristics of Kentucky ideal CT results. So basically, they analyzed mixes that were below 110 and those that were above 110, and how the mixes look according to different characteristics: gradation, asphalt content, reclaimed content. Again, this is all contractor submitted data, unless I'm running your Hamburgs at my laboratory. On top of the 2019 set of data, performance data, they also compared those mix designs above and below 110 to historical mixes, just to get a sense of how these newer mixes compare to the old ones. So they compare additional comparison to pre-July 2019 mixes for the period of 07 to 19. You're not going to be able to read that in the back, but basically, this is looking at gradation. So this is our surface mixes. The yellow line is CT indexes below 110. The green line is CT indexes above 110, and the blue line is the average of those old historic mixes. So don't pay much attention to 3/4 and 1/2 inch, but as we start with the 3/8 sieve, you'll notice the coarser, as we go down each sieve, the green bar, the above 110 mixes, are coarser than the yellow, which are the below 110 mixes. That exists for the 3/8, the 4 sieve, the 8 sieve, the 16 sieve, the 30 sieve. The 50 basically is a wash. And then they're a little finer on the 100 and the 200 sieve. Comparing that to the average of the 07 and 2019 mixes, we've gotten finer for those low-performing mixes. So the lowest mixes we see in the state are finer than the historically average mix design. This graph is for Class 2s and Class 3s. It's comparing not the average of the historic mix, but the min and the max. And again, it's painting the same picture. So the slightly coarser mixes are the green bar, and they are coarser. I think I already said that. The above 110s are coarser than the below 110s. And again, the below 110s are finer than the historic minimum and maximum. Binder. So for mix designs that are above the 110 threshold, they have slightly higher total binder content than the below. Below is yellow, above is green. Blue is the average of the historic mixes. So we have more binder than before, the historic mixes. But the ones that do better have slightly more than the ones that are lower on the ideal CT. They also have more virgin asphalt in them. And they are lower in asphalt content and wrap. That's the final graph on the right. Again, this is Class 2s and 3s, binder minimum and maximum. So again, we have more asphalt percent AC than historically we've had. So when we went to 65 gyrations, 3.5 air voids, we did get an increase in binder content. But the highest performing mixes in the state have more asphalt. They have more virgin asphalt, and they have less asphalt coming from the wrap. Concerning wrap, similar concept. Lower asphalt content in the wrap for the higher performing mixes, higher asphalt content for the lower performing mixes. Cold feeds, so there's actually a slightly more wrap in the above 110s. It's just that I think the asphalt content of that wrap is reported more accurately. So it is possible to put wrap in your mix and get a high result. It's just you have to be more accurate with the asphalt content of that wrap. So a summary. Gradation, we are seeing higher index values for the slightly coarser mixes. We see lower indexes, or our lower index values are finer than the average. So the ones that are below 110 are finer than we have historically seen. Binder content, higher total asphalt content, higher virgin, and lower wrap AC for above 110 mixtures. Compared to an average surface design from 07 to 19, our binder contents are higher for all performance conscious mixes. And then wrap, performance note mixes, so that the performance mixes split the min-max average of the historic. So we're right in the middle of where we've always been, 15% approximately. The lower wrap AC contribution from above 110 mixes, the higher the virgin content. So we did a little, applying those concepts, we did an in-house study. The purpose was to apply these concepts to a lower performing mix that we're seeing in our state. Utilize same aggregate sources as the current design. Our attempt was to use the same aggregate sources of the current mix design without addition of new materials or technologies, simplifying the design if possible, and attempting to exceed performance of a class 4 surface. So above 125 and above 10,000 passes. The current design details, it's a 3/8 surface, consists of limestone 8s, washed and unwashed sands. It has some natural sand and wrap. The asphalt content is 5.7 and currently has an average ideal CT in the 40s. So it's struggling in ideal CT a little bit. It does very well currently in Hamburg. It's above 17,000 passes. So it's a balance. There's no title on this slide, but basically, this is the current JMF. This is the new JMF. The numbers really aren't that important, but the 4-pipe power chart shows the current mix design, or the old mix design versus the new. So we have attempted to go coarser on most of the sieves and then finer at the bottom. Same as the study, the comparison study. We were able to eliminate a sand source. We went slightly coarser on the 3/8, 4, 8, and 50 sieves, finer on the 30 sieve, and no change actually on the 16, 100, and 200 sieves. We added 1/10 of asphalt, and we actually increased the wrap by 1%. So I think it went from 16% to 17% wrap. These are the results of the ideal CT. We were able to get an average of 125.7 with a variance of 12%. So this meets the class 4 level. That's with a 4-hour cure, uncovered, following the specification. The Hamburg. So we didn't have a lot of time to do this. To be honest with you, they were running this yesterday. So we did not meet class 4 for Hamburg. We had an average for the left and right side of 8,046 passes, so that meets a class 2, but it falls short of the 10,000 for the class 3 and 4. So again, the spec is The max rut depth is 12.5 millimeters. Just for your information, in this box, now this is for people who have the APA Junior. This is the output of that. But this max deformation, if you see a number higher than 12.5, that's not a big deal. That's the reading of one sensor. The Hamburg actually shuts off when the middle three sensors are over 12.5. So if you have a number like 14.617, that's completely normal. It's not a big deal. So our findings. Performance is possible with change in the design philosophies. So for a very long time, we've only been concerned with volumetrics. We're now shifting, and I know it's different, to performance. So we're changing philosophy. Additional materials and technologies are not the only answer. KYTC would like to see efforts of improving the designs. So our durability was met for class 4. We fell short for Hamburg. So the mix needed slightly tweaking. Yesterday, we made that change. We took 3% natural sand out and added it to wrap. So we dumped it in a wrap, which put it at 20% wrap. We got an ideal CT of 100. That's my water bottle. But we only made one specimen. And we also only made 2 Hamburg pills. But we were able to get 10,922 passes with an ideal CT of 100. So going from a mix that was in the 40s, but 17,000 passes on the Hamburg, our first, well, it was really our 4th attempt. We got 126 ideal CT, but we were short on Hamburg. We tweaked a little. We sacrificed some ideal CT down to 100, but we were able to get Hamburg. So it's a game. You got to balance. We would need to tweak the mix even more to try to meet both requirements for a class 4. So going forward, as I mentioned, a mixed design approval spec for 1/2 inch and 3/8 surfaces with 64-22 has been approved and will come out in a future letting. Our next move is 76. So 76 and 64 are completely different in ideal CT, and we will do a similar in-house study for our 76 mixes. So we'll have a similar conversation as we move forward. And then there's number 4 mixes. They're completely different than the other surfaces. Plant-produced mixture specification also in the future. Again, there's a need for a quicker test in the field, and Kentucky needs to pick one, start getting some data on that test. Otherwise, the Hamburg's not really feasible for a field test with pay values. But that is the ultimate goal, performance-based pay values to relax volumetrics, to allow more materials, new technologies. That's still the goal. And as a state, we need to work toward reducing variability, so basically becoming like machines and trying to replicate the same procedure every time so that we can reduce variability and make our results more repeatable. That could translate to training workshops in the future. There's been some talk of that internally, but we don't have anything set in stone. So that would be training specific to performance testing, put on by KYTC. Just some acknowledgements. So State Highway Engineer Office, they met with industry quite a bit, also guided us in these efforts. Division of Materials Leadership, so Alan and Robert, kind of letting me explore this stuff. So I appreciate that. Division of Maintenance, helping with all of the rating data, the pavement rating data, and just staying in the conversation with us so that we know what these tests mean out in the field. KTC for all of their data analysis and support efforts They're very helpful. And you all have been running these tests. It's a pain in the butt. You've been running them since July 2019. Additional testing, additional technicians, additional concerns, headaches, and it's on top of volumetrics, and I appreciate it. NCAT and Texas Transportation Institute, two research entities that help us whenever we need them. David Hacker, he's kind of my partner in all of this. He's moved to KTC, but I wanted to single him out. He did a lot of spreadsheets by hand and just put in a crazy amount of hours on this. Brian, again, for his helping me in the mixing of the 30 mixes. I would have died if I had to do that alone, so I appreciate it very much. And then current technicians in my lab, Jake and Chris, and the asphalt field office for going to get materials when we needed them last year for these 30 mix designs. And that's it. Thank you, and go Bengals.
Thank you, Tate. Our next speaker is going to be Shane Buchanan. Shane is an asphalt performance manager with CRH America's Materials, where he focuses on optimizing asphalt mix designs and enhancing production efficiencies while improving the quality of produced asphalt mixes. Shane holds a Bachelor of Science degree from Mississippi State University, a Master of Science and doctorate degrees from Auburn University. Shane is a registered professional engineer in Alabama. Welcome, Shane Buchanan. So it is break time. Mr. Allen.
Test. Yeah.
Well, you hold it like that, it's gonna work great.
Test. Test. It'll work.
Okay, I just about skipped our break when I was introducing Shane a while ago, but our next speaker is going to be Shane Buchanan. Please welcome Shane.
All right, I think I got introduced twice. Everyone here okay? It's a great big room for very few people. I've got a lot of slides that maybe you can't see, so if you want to take some opportunity to move forward, it's just like the preacher tells you on Sunday morning, right? Move forward so you can be seen. So let's talk about rap. How many of you like rap? Everybody should raise your hand, even the DOT. All right. So today we're going to walk through some best practices for rap, and then kind of at the beginning we're going to talk about some numbers, how much rap is really used, and we're going to talk through some benefits, and then we'll kind of dovetail into some best practices. And I've got an hour, and I have an hour and 30 minutes worth of slides, so get ready to go. All right. So why do we want to talk about rap? Right? I think it's critically important. We all want to use more rap for obvious reasons, but we want to use it effectively from a performance standpoint, from an economic standpoint. And those two go hand in hand. All right? Don't let somebody say, well, it's all about performance. It's not. It's all about economics as well. But it's also not all about economics. You've got to have the balance between the two. So the advantages of rap are immense, effective, right? But effective use of the rap, responsible rap use is critical to make sure that we can maximize our rap in a responsible manner. So today, we're talking about basics in use, reasons and benefits to use, processing and management. This really gets into probably what you're interested in from a control of your rap. And we're going to talk a lot about consistency, all right? The best thing you can be with just about everything that you do is consistent, right? Minimize your variability in your process. So recycling is just a big definition, but two key words. We want to take waste materials and turn those into reusable objects, and we want to do this to reduce emissions. We want to do this to save money, and we want to do all this in a responsible manner, right? So rap basics in use. Everybody knows what rap is, hopefully, right? So it's reclaimed or recycled asphalt pavement. All right, this is milled surface, millings. It could be return wrap to your yard. It could be broken asphalt. It could be anything. It could be plant waste. We don't like to make wrap through the plant, but that occurs. Consists 95% aggregate, 5% asphalt binder. First wrap use was in 1915. We've been using wrap for a long, long time, right? And we've been using it successfully, and we can continue that if we follow some good practices. So wrap use and impacts. This is national data, historical data. And these next several slides come from NAPA, their wrap and warm mix survey that they do each year. And you've got a series of curves here. May be hard to see in the back, but generally the trend is upward for DOT, for other agency. This would be FAA type work, commercial res, and then an overall average. So we've been trending upward at about 0.5% to 1% per year. In 2019, there were 89.2 million tons of wrap used. All right, that equates out to about 21% overall. So a significant number, but we could go forward even higher. Always, use 21% wrap, what does that mean, right? So I generated some of these things to kind of reinforce the magnitude of the wrap use. There's about $3.3 billion in savings through the use of wrap. That's a given. That's your economics. Then you get into some environmental sustainability type impacts. So your asphalt binder, that wrap accounted for 24 million barrels of crude or of asphalt not being used, 3 million tons, 1.1 billion gallons of liquid. That's the equivalent of 150,000 tanker trucks of liquid taken off the highways, right? So you didn't have the tankers. You didn't have the safety issues with unloading and loading that liquid. Your aggregate, 84 million tons. That's enough to fill up 19,000 Olympic-sized swimming pools. That's a huge number, right? That's aggregate that got to stay in the ground for a later time. And then landfill space. That saved 60 million yards of landfill space. That's enough to fill up about 15 of the Cowboy stadiums in Arlington. A really big number, really significant impact environmentally. Average contents by state. This is total content. 15 up to 19. You can kind of see Kentucky here. For reference, you were at 16, I think, percent overall in 2019. This is a national summary of the data. It's kind of maybe hard to see from the back, but if you look average for DOT mixes, in 2019 you were at 20.1%. Right? Kentucky, average for DOT mixes in 2019, 14.7. So you're trailing a little bit off the national average. Now you might say, what's other states doing? This is a slide. This is DOT RAP use on average. For the states along the bottom, this is the national average at 20.1. The blue line is just the representation of the states. Kentucky's sitting at 14.7. Could you go higher? Probably you could. You've got some neighboring states that are higher than you for whatever reason, right? So reasons to use RAP. First off, it's really complying with federal highway policy. They have a recycled material policy that states that RAP should be used if it's proven to be quality from a performance standpoint. Then you've got material supply issues. You may not have it locally, but there are supply issues with liquid. There are supply issues with aggregate and getting permits, making sure you have adequate reserves. There's asphalt pricing volatility, especially this year. We've seen that. And then sustainability. Sustainability may not be a key important thing that you think about every day, but it will be at the forefront of transportation agencies, contractors, and the overall industry going forward. That is an absolute bet. All right? And then finally, but certainly not last, the economics involved. So this is federal highway recycling policy, and you can link to this. I won't read all of this, but it says recycled materials should get first consideration in overall materials use, right? And it's got some other stipulations. You got to make sure that it works from an engineering and environmental property standpoint, right? Asphalt supply. Got some asphalt suppliers in the room. Asphalt is constantly changing from a supply standpoint. You may get liquid today. It may not be the same that you get next week. It may not be the same that you get next month, right? It changes based upon the crude stock that's coming in and the products that are cut and manufactured. And recyclable binder can help buffer some of the volatility. This is asphalt binder index from New Jersey, right? And I think this goes back from January of 2005 to current day. Liquid has gone up, it has gone down. The band here in the green, that's the delta in pricing that will give you a $5 per ton mix impact, right? So we are currently going up, 500 to 535, 550 for virgin asphalt binder, right? That number probably will go higher the rest of the year, if I had to guess. I think crude is about $100 per barrel. Rule of thumb is 5.5 to 6 times your crude is your liquid price. Right? So that generally holds true. If you thought about future supply of binder, what's going to happen when we increase fuel mileage? Right? That's a consideration. We're going to electric vehicles. That's a consideration. So all of these things will drive down crude demand. If you're not refining crude, you're not making liquid asphalt. All of these will impact supply. Right? So it's not too early to start talking about and thinking about how you can kind of set yourself up for stability and success long term. Aggregate supply. You've got limited reserves in a lot of the locations around the U.S. This is especially true in some of the urban locations. And you've got increased difficulty in permitting new facilities. It is extremely difficult to get a new quarry permitted. right? So the more that you can use, or the less that you can use and keep that material in the ground, the better. Kentucky quarries. How many of these locations could you go back and get permitted today? I don't know. Maybe all of these. Chances are you would have difficulty in getting these re-permitted if you were to start from ground one today. So just a consideration. The state of Ohio, they've got a study on shortages and impacts of aggregate supply. Quote here, a greenfield site, that's a new site, it's almost impossible to get permitted at this point in time, right? And I would assume that that's the case in many, many states. So quick math, at 20% RAP, we're saving 19 years worth of virgin aggregate over the next 100 years, all right? If you've ever thought about it in simple terms, that's certainly applicable. So the best way that we can be sustainable from an aggregate standpoint is make the residual material, the recycle, bring that back to the current supply of your aggregate, and you've got the closed loop on sustainability. And what is sustainability? All right. If you haven't heard of that term, you're about to get totally sick of that in the next 3, 5, 10 years. That is a point of emphasis to a large degree within the industry. NAPA has put out a path forward for sustainability. You will be hearing more and more and more about this. So sustainability, you can think of it as a three-legged stool: engineering, environment, and economy. And sustainability is where all of these intersect. All right. Federal Highway document on strategies for improving the sustainability of asphalt pavements. Right. And a clip or an excerpt from that. Recycled material should be used for the highest use. What's the highest use? The highest use is to replace virgin asphalt and aggregate in new asphalt concrete. Right? That's what we should be doing. But we should be doing it in a very effective manner from a performance standpoint. Greenhouse gas. All right? Believe it, not believe it, climate change, believe it, don't believe it, it really doesn't matter. It's coming. All right, and you've got to be prepared for it. So last year, that 89 million tons of RAP was the equivalent of taking 520 passenger cars off the highway in the U.S. That's a significant impact. All right, and the economics, I mentioned the $2.8 billion in savings last year. It's just quick math. Everybody knows how to calculate your savings. Economics is critical. It should not lead the conversation, but it should be in the conversation. So now let's talk about processing and management. How many of you process your own RAP? Producers. Everybody should, right? Everybody raises their hand. Everybody does it correctly, right? Everybody's got the best method, right? And you may do it. These are some general steps for a quality product. So number one, you get your RAP, right? Number two, you crush and screen your RAP. 3, you stockpile your RAP. 4, you test your RAP. 5, you use it, and then you test it again. And then you get back on the wheel. And this never ends. So obtain the RAP. Is it millings? Is it broken concrete? Is it plant waste? Right? You got all three at your facility. The key is to figure out how I can separate my millings from my returned RAP from my plant waste. How do I know what's in the stockpile, right? From a consistency standpoint, that is super critical. So processing your RAP. You got millings, broken asphalt, plant waste. Effective processing begins with proper storage and sorting. When you get returned RAP back to your facility, do you ever inspect it? Do you ever look in the trailer to see what's in there? Chances are you can have a lot of garbage in there if you don't check, right? Dirt, sticks, toilets, you name it. It could be in the back of the truck, right? You need to be taking a look and inspecting trucks. You kick one truck out, you'll have cleaner RAP the next day. So sort RAP based upon the product and the desired end use. Right? If you're milling a state job, bring those back, and those millings go back in the state job. That's ideal, right? So millings, general RAP, agency RAP. You can have captive stockpiles, or you can have continuously replenished stockpiles. I'm not sure what's the specification is in Kentucky. Either one can work, provided you stay on top of the testing. So crushing and screening. You need to screen the wrap first. That is the number one rule. Don't crush wrap that doesn't need to be crushed because it exposes more fractured faces, more open surfaces to the wrap. It creates dust, both of which are not advantageous to you from a use standpoint. So screen it and then crush it or break it apart, preferably if needed. The goals of crushing. Number one, make sure you have the correct top size. That's a given. And break up the wrap, not necessarily crush it. All right? And then three, have a target grading that you're trying to hit. Don't just say, if I'm here to here, I'm okay. Always have a target. You may not hit it all the time, but you need to have a target. And then shoot for consistency. If my target is here, I want to hit it on Monday, Tuesday, Wednesday, Thursday. Right? I don't want to be here and here. All right? Crushing, screening, stockpiling operations. A lot of our locations use portable crushing operations. I would guess that you do. Sometimes you have third-party crushers that come in and crush your wrap if you've got sufficient quantity. Horizontal shaft impactor crushers, HSIs. They're very good. They're very common as far as getting your wrap processed. And they're good because they allow you to really vary the rotor speed so that you're not spinning it too fast. You're spinning it to the degree necessary to break up the wrap and not shatter the wrap to a large degree. Crushing the wrap, if you don't have to, don't do it because it's a huge negative. More water, more binder, absorption, more dust, and then you're going to have less binder content per ton of wrap that you're using, and that's a huge issue, right? And then set up your processing to yield the most desirable product, and generally it's 5/8 to a 1/2 inch top size on your wrap processing. I would guess that that's applicable for most in the room. So we ask internally, in CRH we have 65 companies. We made approximately 53 million tons of asphalt mix last year. We used about 22% wrap, right? And we operate in 42 states. So this is coming from a lot of different companies, a lot of different perspectives. 59% of our folks were at 59%, passing our top size at a 1/2 inch. The next was 22%. Very few off of that as far as a target top size. Here's some clips from some of our operations. Probably look very similar to what you have. This particular location is Pike Industries in New Hampshire. This is where they're processing their wrap, loading it into a portable crusher. This is an HSI crusher. Again, it's not complex. To the bin, feeds over to the crusher, breaks it up, and you've got kind of a closed loop system, much like you would with any crushing operation. So the material's being fed in. The unders go out, the overs get crushed, right? And look at the wrap pile that you had versus the product that you have on the end. If you take your time and you process wrap the way that it needs to be processed, your resulting product will be very consistent and of high quality, regardless of whether or not you have multiple wrap sources in that overall pile to start with. Guarantee it, right? Right? And then what's also evident here is they're sampling from a miniature stockpile, bringing their material in for laboratory testing. Now look at this. How many of you have wrap piles look like this? Everybody, probably. All right, so this is a God only knows pile, a gawk pile, or whatever. All right, so they're bringing the material out. You've got a portable crusher, right, feeding the material in. Series of conveyors, finished product. Right, very clean, consistent product. All right, processing wrap in Maine, another finished stockpile. Another stockpile there being made, finished wrap in Texas. I show all these pictures to just show you that good practices travel. It's kind of like playing football. Defense travels. If you do what's right and you process it right, it doesn't matter where you're at or what wrap product you have, you can get quality out from an end result. How many of you use inline wrap crushers at your plant? Some of you maybe. If you haven't, this is what one of those devices or setups would look like. These are very effective if you have limited footprint to store your wrap. All right, this is essentially you're taking your wrap and you're doing the crushing operation on the fly with a closed circuit inline wrap crushing unit. These can be great, right? But a word of caution on this, it takes a little bit of getting up to speed to make sure that you know what's going into the plant is the desired product, right? So you're crushing and you're screening your wrap on the fly. So what's crushed, what's screened, guess what? It's going to the plant. It's not going into the stockpile. So what you see is what you get. You need to sample frequently to make sure you have consistency. And you can do this in a bunch of different ways. If you have belt sweeps, you could do manual sweeps or sampling. And then generally just overall pay attention to the feed to make sure you have uniformity and consistency. And this is a closed circuit system, kind of showing you all the points. This is your wrap, your recycle bins. All right, you've got a grizzly there to knock the oversized off. A material, the unders go down, the overs would go to the crusher on the return. So your product that's going into your plant is a mixture of the unders and the overs that were crushed or broken apart. So that composite grading now is what you need to make sure that is on the target grading for your wrap. Right? Fractionating wrap. Right? How many of you fractionate? Keep squinting because the light's right here. Right? Some of you probably fractionate, some of you don't. Screening wrap is not fractionating wrap. If I just screen the top size off the wrap, I'm not fractionating the wrap. To me, fractionating is three sizes for a specified use for each, right? And the primary advantage of fractionating wrap is to make sure that you can have flexibility in your design. A lot of people will argue that if I fractionate wrap, it's more consistent. That may or may not hold true. Certainly doesn't always hold true. But typical size is 3/4 by 3/8, 3/8 by 3/16, and then minus 3/16, and you see the different sizes over here. My personal opinion is that fractionating should not be required, should not be a blanket requirement. If I can prove that I can make the product by not fractionating the wrap, then I should be allowed to do that. But I need to prove that, right, on my end. But fractionating should be considered maybe if you've got multiple wrap stockpiles, you've got a problem meeting design requirements, maybe you've got volumetric issues and you need to dial it in perhaps. So use it if you have need, don't have a blanket requirement. And then stockpiling wrap. Wrap is no different from a stockpiling standpoint than virgin aggregate, right? You can still screw up a good processed wrap by poor stockpiling practices. So if you have wrap going on a conveyor and it's going off the end, the big rock wants to fly off farther than the small rock. It's physics, right? So all the practices limit the drop of the material to the stockpile. That's good. You need to be aware that when that conveyor is going and shaking, the fine aggregate's going to the bottom of the belt, right? And the coarse aggregate, larger aggregate's on top, right? If you've got the ability to use a radial stacker, and you may not be doing this with wrap, but radial stackers obviously work better than fixed point or fixed stackers. You're allowed to kind of spread things out to reduce variability. Wrap moisture. How many of you cover your wrap stockpiles? You absolutely should. Absolutely need to cover your wrap, right? That is best practice 101 there. Do we always do it? No, right? But you should, right? So moisture control and monitoring is key. You've got all kind of different variations for wrap covering structures. And I just put this picture in here. This is our operation in Tampa. We bring material in by rail. We stockpile that material. This is just virgin ag, but you can see the water draining out of this. Water is the biggest killer of quality that you can ever have with your asphalt mix. But it's also one of the easiest things to mitigate if you'll spend the time, the effort, and the energy and the money to implement some mitigation strategy. And you might say, moisture, it's not a big deal. You know, what's the big deal on water? Water's huge, right? So if you've got 100 by 100 square foot stockpile, and it rains 1 inch, which it does here all through Kentucky quite often, you're getting 100 by 100, you're getting 26 tons of water on top of that wrap, or on top of that virgin ag, or whatever your stockpile is. Now that water has to either drain out or be dried out at your plant, right? Either one is bad, but if you're drying that out at your plant, it's costing you money from a BTU standpoint, and it's costing you quality from a lack of consistency standpoint. There's no way you can feed in wet wrap and be consistent with your liquid add, with your overall grading. It just very rarely will happen. So the best solution is to keep the water out of your stockpiles. All right, that's all stockpiles, especially fine aggregates, and really especially your wrap. As a sidebar here, every 1% moisture will impact your BTU cost at your plant by 24,000 tons of BTU, whatever that's costing you. If it's natural gas, propane, recycled fuel oil, whatever. So there's a cost. Sampling of your wrap. I mentioned the miniature stockpile, and that's the preferred way to get a sample, in my opinion, of any material, especially fine aggregates. Right? Loader operator comes in, 2 or 3 or 4 scoops, back drags to the top, flat surface, sample around the top to get your sample. You split it, you bring it back to the lab for testing. Your test result is only as good as the sample that you take, right? And it is only as good as the technician that is running the test and the procedure that he or she is using. We talked a lot about coefficient of variation earlier. You can screw up a good mix by a poor test procedure or method of sampling, right? 50% of the variability could easily be in operator and overall sampling, right? And you're trying to get to the material or to the mix variability. You don't care that you've got variability with technicians. And then wrap testing, what are you running on your wrap? Obviously, you're looking at binder content, gradation. You may or may not be trying to back calculate the bulk specific gravity of your aggregate, and you may be getting a true PG classification or a true binder grade for your wrap aggregate. I would encourage you, if you don't know that number, that's probably a good thing to have just internally, right? And that's the overall process for a miniature stockpile. Wrap binder true grade, continuous grading. You get a PG grading for your virgin ag. That wrap binder in your stockpile also has a true grade. And from a paper or theoretical blending standpoint, knowing that wrap binder grade and your virgin binder grade, you can marry those two and kind of figure out, at least on the surface, what your overall resultant grade would be, right? This assumes a lot of things. It assumes 100% blending. It assumes that wrap pile is consistent top to bottom. Both of those may or may not hold true, but it gets you started in the right direction, sets you up for success. Now, how often to test your wrap? These are some recommendations from NCAT. 1 sample per 1,000 tons of wrap consumed. So if you're bleeding down that wrap at your plant, every 1,000 tons you pull a sample, make sure that wrap is what you think the wrap should be. Your goal is to have the lowest possible variability that you could ever have. So maximum standard deviations recommended by NCAT for asphalt binder content, 0.5%. Percent pass in your median sieve. That's your sieve closest to 50%. That's 5%. Percent pass in your 200, 1.5%. And I can tell you, I think these are too high. Right? I think these are not conservative enough from a producer standpoint. Right? But they're good starting points. I won't ask the question, but how many of you know for your largest wrap pile at your largest plant what all 3 of these standard deviations are for that wrap? If you don't know that, I would suggest that you go back and you figure that number out, because if you don't know that, you're producing mix blindfolded to a large degree. You absolutely have to have that. So if you've got high variability wrap, you've got two choices. You can either use less of it, or you can do something to improve the consistency of that. Loading wrap into the plant. Use leading practices for stockpile loadout, just like Virgin Ag. Keep the bucket off the ground. Make sure you're not getting moisture in the material if it's really wet. If you're covering your wrap, that's probably not an issue. But all the loading practices, best practices for loadout should be followed. Right? Years ago, and it's not in here, but years ago, one of our companies looked at a natural sand stockpile, and this was 24 hours after a 2-inch rain. And they found that the bottom of that stockpile was something like 20% moisture. All right, so where does the loader bucket typically go when going into the stockpile? Let's just say it's before daylight, right? It's dark. Loader operator, he or she, it likes to hit the bottom, likes to hit the ground, scooping up wet material. You feed that wet material into your plant bogs down, right? Bad things happen when the plant has moisture, right? It just does, right? And then your recycle bins, make sure you have grizzlies, make sure you have no flow limit type switches. You can have steeper sides in your wrap bin. You can have vibrators on your bins. You can even have air cannons on your bin. All of these things you may find value in doing. The main thing with this is make sure that you have consistent feed of material from your bin onto your belt into your plant. If you're running high wrap and you figure out that the wrap's not coming in, you could have a huge safety problem with your plant, right? Because you're starving that plant of material. Wrap consistency. You can take a picture of this because this is a really great slide, right? And it's really great because I didn't make it. I lifted it off the internet. Nobody's perfect. No operation is perfect, but every operation can be consistent, right? That's the number one takeaway from today. You've got to be consistent in your operation. Make a consistent product, and you'll have consistent performance, and you'll get paid on a consistent basis as well. So, quality is the inverse of variability. And variability is standard deviation. You all know about deviation. The higher your standard deviation, the lower your quality because your process is not controlled. It's chaotic. Standard normal curve for all the statistician geeks in the room, right? Normal curve. Construction materials follow a normal curve. Half your data on the left, half your data on the right of an average, of a mean. Plus or minus 1 standard deviation is 64%, plus or minus 2 is 95, plus or minus 3 is essentially everything for that population. If you understand stats, you can make yourself a lot of money as a producer because you know how to manage your materials to limit surprises downstream. I preach this all the time to our folks. Look at what you've done in the past, predict what you can do in the future, and if that prediction is not good, make changes before that prediction comes true. And then accuracy and precision here. What you want is an accurate and precise process. You're hitting the bullseye every single time, right? What you do not want is something where you're just chaotic. You may be low, you may be high, you may be in the middle, you just don't know. It's a random number generator process. So what should you know about your wrap? I think you should know your true PG grade, your residual binder content, average and standard deviation, aggregate grading, average and standard deviation, moisture content, and GSB. All right. So let's quote from Henry Ford, if you've always done what you've always done, you always get what you've always got, all right? So if you're not testing your wrap to make sure it's consistent, you're behind the game. You need to really get up to speed. A lot of people will say my wrap's not as consistent as virgin aggregate. I think that's a total false statement. Your wrap was virgin aggregate at one point. It went into that plant as a virgin aggregate. It got processed. laid down, brought back, got reprocessed. So your wrap can be as consistent, if not more consistent, than virgin ag. This is an NCAT study from several years now that shows just that. Your wrap compared to virgin aggregate has a lower standard deviation. Other data, other studies kind of show similar type findings. Federal Highway, NCAT, ICARS, International Center for Aggregate Research, Texas Transportation Institute, all these show similar findings. So the argument that wrap is variable, I don't think holds truth across the board, right? Example wrap data. This is wrap versus virgin aggregate. And we've got, keep looking over here because I can see that screen. This is our wrap in the gray, right? And we've got a number 7 stone in the black, 89s, yellow, wash 10 in the blue, natural sand in the green. So is there anything about your wrap product that would stand out as being excessively variable compared to some of these others? Keep in mind that wrap is a continuous product from a 1/2 inch down. All right, your 7s and your 89s all have kind of limited ranges. Takeaway from this is that wrap is just as good as any virgin aggregate that you can get, right, based upon this. Right. This is general wrap millings versus aggregate. So this is a general wrap stockpile in the light gray. Your black is your millings, and then you have 1/2 inch rock, 3/8 rock manufactured sand. Your general wrap matches up reasonably well with your millings. Right? That general wrap stockpile can be processed very consistent if you follow the good practices. Multiple plants. We've got 4 plants, right? A, B, C, and D. This is the variability of your wrap across these plants. Very similar, right? And standard deviation of 5 on a clean stone is probably, that would fall into the good category. How many of you have aggregates that are 8, 9, 10 on standard deviation? Right? We have some of those. That's not good, right? And consistent wrap's a consistent mix. So we've got our 1/2 inch wrap in the gray, and we've got a mix, 9.5 PG64 with 15, 25, 30% wrap. You know, this goes back to good material going in, good material coming out from a variability standpoint. Right. So we asked the question, what's the standard deviation of your median sieve of your wrap? And 46% of our operations said 3 to 4%. If you go back and look at your data, which hopefully you have, and you say, okay, my standard deviation for that median sieve is 4%, you're in good shape, all right? If you're over here greater than 6, you need to do something to that stockpile. You need to investigate why that material is so variable, right? And don't base this on 3 tests. Take enough tests so that it's meaningful, right? Running a gradation is cheap, right? But it provides you a lot of data that you can use to your advantage. Variability on the 200, the same survey. We had 30% for 25 to 50, 0.25 to 50, or 0.5%. Likewise, anything over 1% on the 200 from a standard deviation standpoint, you need to dig deeper into the problem, figure out why that is. And some of you are thinking right now, I don't know these data from my wrap piles. I can't urge you enough. Go back and figure that out. You've got to know this. Wrap binder content, variability. 3 plants, we're at 1700s, 2100s, 2300s. That's really good for wrap, right? The gold standard almost for an award-winning job from a total binder variability standpoint, deviation, is around 1200s to 1500s. That's about the best that you can get, right? So your wrap here, very, very good. So what's better wrap? We talk about this a lot as a company. What's better wrap? Better wrap would be one that has a higher binder content in the stockpile. More consistent grading, more consistent binder content, and less dust. Right? This is a good wrap. When you can get all of these, that's a good wrap. So tips, monitor the wrap coming in, segregate wrap sources if you can. I recognize footprint's not great in some locations, but if you can stockpile multiple wrap sources, that's to your advantage. Process, screen, and crush correctly like we talked about, and then fractionate if it makes sense. So managing your wrap, here's an example, a couple of examples. Case one, we have increased our residual binder, that stockpile binder content of that wrap by 1/10, just by better processing and management. Didn't cost us a dime, right? So the cost, $5, doesn't matter the cost, it's just relative. Wrap cost per wrap ton is $5. Stockpile binder content went from 5 to 510. Your binder replacement went up by 4/10. It's a big number. It's really a big number at $535 liquid. So your binder replacement impact is 4/10. That equates out to about a dime saved per mixed ton. We live in a world of pennies. If I can save a penny on a mixed ton on 53 million tons, that's a pretty big number, right? Don't throw away pennies. Pennies matter, especially when you hit the calculator volume button. Like case two, we have done something different. Maybe we've brought in a different screen, all right, or for a wrap. And we drove the binder content up by 0.5%, but it cost us $3 to do that. Maybe that's fractionating. Our impact here, even though it's costing us $3, we're still, I think that's what, right around 48 cents savings on a mixed ton. That's a no-brainer. Do it all day, right? Don't fall into the old trap of thinking that just because I haven't done it in the past, just because somebody hasn't told me to do it, that it's not a good idea to do going forward. I think that as an industry, I think we fall into that trap a lot. I think I killed it. Let's have a timer on it or something. There we go. One more variability, what if? This relates back to binder variability for your wrap. This slide here is a given. Let's just say that our historical binder variability standard deviation is 0.3. Not great. We've got 30% wrap. Historical asphalt binder variability is 0.3. That's overall. Our binder stockpile variability is 0.5%. That's not really good at all, right? Wrap contribution to the total variability is 0.3 times 0.5. So it's 1/1500ths of your variability is coming from that wrap. And what did I tell you the gold standard was for overall binder content variability? 1/1200ths to 1/1500ths. You're eating all your variability up with your wrap. You have no room for variability from your virgin add. Right? If you run through 5% plus or minus 1, plus or minus 0.4 with n equal 1% within specification, just quick math, you're at 82%. That's not good. Right? You need to do something, do better. So we go back and we better control our stockpile here. We use 30% wrap with a binder's variability of 0.2 compared to 0.05, or 0.5. Our new estimated asphalt standard deviation is 0.21. Right? The result of there, we went from 82 to 94.3% within specification, just by improving our wrap, right? This is money. It's money saved due to non-conformance, right? It's better performance due to more consistent mix in place. It's also more consistent density, longer lasting pavement. All these things are good. Bear with me. All right, just a quick sidebar. If you're generating data, don't look at tables only. Graph your data. Graph it, graph it, graph it. you can be fooled by tabular data. This is, I think it's called Anscombe's Quartet, a series of 4 graphs. All of these data points have the same mean, standard deviation, variance. If you were to look just at this, you'd say all of these are the same. And that is totally wrong. So generate your data, have a table, but always graph your data. That's why we use control charts. That's why we use scatter plots, trend analysis, all of these things. And now finally, I'll just leave you with some slides on performance. All right. This is a fairly dated study now, but if you go back and you look at the SPS 5 sections years ago, right, they concluded that wrap pavements could perform equal to, if not better than, virgin pavements for up to 30% wrap. Right? That was pavements constructed before we even have the technology that we do today. Those were probably constructed without any rejuvenation, without process control to the degree that we have today, with older type plants. So we're getting equal to, if not better, performance. We certainly can do that today. NCAT Test Track, they've looked at wrap for several cycles now, right? And they found success up to 45% wrap with minimal cracking. And that, from an agency standpoint, I think that's what you're trying to do here with your ideal, with your Hamburg test. I think that those tools give you the option of deciding and really putting a number on performance. And I think that's critically important. I think the key going forward is to have these tools in place, but also allow for innovation on the part of the producer to hit the performance measures that you have in place. I think those two have to be married together. And I'm not saying let the producer run wild. Absolutely not. But if performance is your proof of, if an ideal is your proof of performance, and I can give you 125, and my air voids are 2.8, then air voids really shouldn't be the driver, right? You can't have the recipe and then expect a different outcome on the end. That's just my opinion. NCHRP report 752 talks about being able to go up to 50% wrap, right? Equal to, if not better, performance than conventional mixes. So the wrap future, just kind of closing up. The future's in performance, right? Balanced design with whatever test that you choose, right? And you got to remember that when you get into balanced design, this whole consistency concept, limiting your variability, that will become more and more important than it ever has in the past. Balanced mix design will reward the producers in this room that have an eye for quality and consistency in their operation. If you don't, you're going to get left behind. And it will happen very, very fast. So performance testing, balanced design. I think these are key. There's many questions. I get asked all the time, what's the GSB of the wrap? My response generally is, who cares, right? How much binder is coming from the wrap? My response generally is, who cares, right? Prove the performance. I don't care, right? The wrap in the binder in the wrap, if it's effective, that's good. If it's still in the wrap, it's satisfying the absorption capacity of that stone, right? So it's serving purposes either way. Avoid the recipe. Let the producer, let the estate innovate and engineer the mix for the performance that's required. And then balanced design. I'm a big Game of Thrones fan. All right, so BMD is coming. It's probably already here. So what we're trying to do here is to make sure that you have a good mix, a stable mix, a durable mix, one that's in the sweet spot that lasts for a long, long time. That's the goal of the industry, whether it's producers or the agency. So wrap can have a lot of benefits, all right? Substantial benefits, sustainability, less resources used, economics. You've got to pay attention and process it so that you have quality in your mix. And then BMD is absolutely the future. Whether or not you like it or not, it's here and it will stay. Some key references, and I think this will be posted on Brian's website. You can take a look at some of these. They're all, I think, hyperlinked. I think the links work. This is the Federal Highway Materials Policy, Federal Highway document that I referenced. Some great documents here on RAP and RAS management and synthesis of use. These are from NAPA, great resources. The NCHRP reports and the Federal Highway report. And with that, I'd be happy to answer any questions if we have time. Any questions? How many Kentucky fans? How many Louisville fans? All right. Other. All right. I'll be other. All right, no questions? Well, once again, I appreciate the invitation from Brian. I came here in 15 and 18 and now 2022, so maybe I'll get back in 2 or 3 years. All right. You got my information. Give me a call, shoot me an email. Be glad to help you. I don't care if you're. I try to help the industry if I can, not just CRH or AMAT type companies. All right, appreciate it.
Okay, our next speakers are going to go over the new KDA specifications for general aviation airports. Scott Quire and Phil Blankenship. Scott Quire is the technical director for Bluegrass Testing Laboratory. He's a registered engineer in Kentucky and Alaska. Scott has over 30 years' experience in the design, control, and placement of asphalt mixtures for racing courses, highways, commercial projects, and airport pavements across the nation. His experience also includes the testing and oversight of construction materials and testing and training courses for construction materials testing. Phil Blankenship graduated in 1991 with a BS in civil engineering and in 93 with an MS in civil engineering from the University of Kentucky. During his graduate research at UK, Phil worked at the Asphalt Institute in Lexington and the Strategic Highway Research Program. He assisted in developing InDesign to simulate field mixture compaction in the SuperPave gyratory compactor. In 2017, Phil started Blankenship Asphalt Tech and Training to open a consulting engineering company that uses his agency, industry, and association combined experience. In 2019, he opened an asphalt testing laboratory focused on pavement innovation. Please welcome Scott and Phil.
Are you doing the song or the dance? What we do?
Let's do it. Let's go, big guy. Phil and I are going to tag team this, and we've never done this before, Phil, like this.
haven't.
So this will be a first time, so we're going to throw this at you.
Maybe in 1994 or 5, Scott, we did something together. That's
Well, we'll start off and go. I've got way too many, kind of sounds like Shane Buchanan. I've got too many slides for this time allocated, so let's just take off and go here. Statewide aviation pavement, the Kentucky Department of Aviation's airfield pavement spec, there's a timeline on how this processed, and it's all been going. We've been working on it for a couple of years, and we got derailed for a short period of time after they changed directorship. And then we picked this specification right back up. This is kind of the agreement. I think, of course, Gary had gone through that. You probably went through that yesterday afternoon, I guess, to some degree about, where all that stood. And the bottom line is, as we go through this, I'm going to jump back. They're talking about, I guess, first of all, the summary. Why? All right. As a mix designer for airfield pavements, I've done, as far as airport mix designs through my career, done a lot of them. I've also worked from the perspective of doing the acceptance testing on many number of airports across, Kentucky and other states as well. And then in turn, have worked, in consultation on airfield pavement. So my background is that, as we're all painfully aware, especially coming from the contracting industry, many people have an angst to some degree about the FAA P401, P403 specifications. That plays in many ways, in some cases, into the bid numbers. I don't think I would be incorrect by saying that, I don't believe, and Gary, I think that's correct. But also, one of the other things too, is we looked at this specification, we're looking at, if you look at an airfield pavement, and in spite of the stringent requirements that you'll see in an FAA P401 specification or P403, that with the expectation that pavement quality would come with that, there were still problems with performance. And so there has to be a better way. And so the Kentucky Department of Aviation graciously allowed our team to come up and walk in to write this specification that would address multiple points. And so with that, we began the process, and I guess the heavy lift into the specification on the initial draft fell on me. And so as I looked to write the specification, I guess my warm-up words as we jump into this presentation is that how can you take the P401 specification, write it close enough to where the Kentucky contracting industry is more comfortable with that? We also have to address the concerns the FAA would have with this, because if there's a thought that this specification as we've written would be one that the FAA would adopt and accept, we have to address their concerns. And so with all that said, we tried to, as we wrote the specification, as I wrote it initially, and then our team put all the add-ins into it, that's kind of the mindset behind this specification, right? So with that, I'm going to jump in here real quick. The sections in this specification, there's 9 sections in it. And Phil, I guess we're just going to work off this, and so I'll just keep held up. If you see something, jump in.
I will do it.
So of the 9 sections in this specification, and again, because my slides are so many, I will probably just kind of lightly go over a few of the slides as I go. The description, section 1, is just basically an overview of what's expected if you're using a specification and, you know, in consideration of construction of the pavement. And then we get into the meat of the specification, and we start in section 2, and it addresses the materials. And so for all you contractors, mix designers, what you're familiar with in a P401, a P403 specification, there are many common elements that you'll see as we look through this. And so in turn, that'll kind of give you an initial background. So on the aggregate section, there's coarse aggregates, fine aggs, and mineral filler. And as you get into it, this is just an expectation of what the allowable materials are. That would match up pretty well with words you're going to find in the KYTC standard specs section 804 and 805. So you'll notice that as well. When you look at the specifications, though, again, and trying to think about the P401, P403 aggregate expectations, those limits that you'll see will be ones that you're familiar with seeing, so there's no big surprises in that. Also, you will see that the ag data that's allowed, if I can get this laser pointer to go, down here at the bottom, your ag data has to be 1 year or less. The other big thing that you're going to notice, if you're familiar with P401, P403, they all reference ASTM standards. And so one of the things we were trying to do is try to open this up so that the aggregate data that would be accessible, for the most part, like on the sodium sulfate soundness test and the LA abrasion data, that would be data you can get from Materials Central Laboratory. So that would be a viable source for that, so that would leave the contractor not having to have soundness and LA data generated. You could get that from the state. And so you'll see that some of these tests, though, you're not going to find in Materials Central Lab's database, and so that would be required by the contractor to get that testing done or perform that data. Similarly with the fine aggregate, these are specification limits that you would see in many cases in P401, P403. Again, there's a 15% maximum natural sand allowance in this. As we get into this, you're also going to see we got performance testing built into this. So with Hamburg testing built into it, that's something that you would be well and sensitive to, because the natural sand potentially could cause problems. Helps on compaction, but it also has problems with wheel tracking, so you have to be aware of that. Mineral filler specifications, it just references AASHTO T90. And here we get into one of the big game changers of this specification. On the asphalt binder testing portion of it, we're using multiple stress creep recovery binder test criteria for the expectations of the binder you use. And so when you look at the engineer, when he makes a selection of the binder grade to use in whatever application, there's a table I'm fixing to show you, but the considerations that they've got are aircraft gross weight, the pavement locations, and what state of moving or turning or stationary movement of the pavement or the aircraft is taking place. And then also available binder additives such as aramid fibers and crumb rubber. And again, that's something that's not been part of P401, P403, so we've written that in, and you're going to see that here in just a second. The standard startup grade is a PG 64S-22, the standard 6422 that we're all familiar with. When you look at the required grade bumps, so as an engineer looks at a pavement or a given project, and in consideration of the aircraft that's using that airfield pavement, this is what he's going to be looking at right here. So in turn, when you look at the vehicle or the aircraft gross ratings, weight ratings, this kind of drives them into the selection of your binder grades. And so you'll notice that if you go over here with pavements with slow turning and stationary aircraft, you can actually work all the way up to a 3-grade bump. And so as we get into the binder grade selections, you're going to see what that might look like. So the first grade bump option would be a 64H-22, which would have been our old legacy grading, that'll be the term we use, of a 70-22. We don't have a KYTC 70-22 binder grade that any of us use, but in turn, relative to the 1 grade bump, that's what you would look at for this one. Initially, this got added in because there is a 70-22 that's available, 64H-22 with SBS modification. And we wanted to force the issue that we want polymerization in that 64H-22. So when you're doing MSCR testing, that's why that's written in there in such fashion. And then in turn, we also built in the wording for aramid fibers and crumb rubber. And Phil, you want to say anything about that on the?
Yeah. I'll just brief on it. So the challenge gets to be when you look at these airports, and Scott and I were talking about this, that the airport guys don't like you to refer to this as a highway, period. And it's not, okay? You're looking 100 plus feet, typically 150 feet wide, wide open to the elements, and it just sits out there and loaded every once in a while, and durability is such a key. But in making changes to what we're doing, we got to take some handcuffs off. So we're trying something, but it's on trial projects as we begin to put these out. So what we want to do is allow the contractor some options instead of having to necessarily the old bump that we would make. We want to allow some options of modifications. There are different modification ways that we can try, but what can you do at the contractor's plant? I continue to say the day of the contractor's here. So contractors can't, in the typical world right now, make your own SBS. You probably could, but I think you'd end up with a hockey puck, Scott. And so, but what you can do, as you've seen the terminal, or that you've seen the rubber process that we can begin to add, or you can add aramid fibers at the plant. So that's exactly what's going on here. You're going to see the next slides that Scott's going to present, and allowing additional dosage of each one of these, and you're finally going to see sort of the super binder that comes in that raises everything up to the whole other level. But again, you're allowing, what you're just seeing on here, you're allowing the option to use an aramid fiber, which is, what is aramid fiber? It's polymer, guys. Think of it as a dry polymer that goes in, and it's not waste product, okay? This is aramid is polymer, and it's going in a very unique way, so it's a reinforcing fiber. What is rubber? Rubber is another polymer, okay, that goes in, and it gives you that elastomeric component that you need for durability. Gary, I think we've said over and over, you said they've got to last longer, we got to meet the FAA spec, and we don't want to raise cost ridiculous on this. So again, this is how we're trying to hit the durability piece, but keep it between the lines. Scott, I'm going to leave it there and let you just.
We're going to tag team it like through this presentation. I'm going to look at you periodically, big guy. So. But anyway, on the 64H-22, 70-22 legacy terminology, this is what this would be. One of the things is, we're standardly familiar with, like on a highway department application, some of these airfield pavement specs, when we look at binder grades, we were trying to derive the pavement performance and the bumps and binder grades to derive the performance expected, anticipated. We're all very familiar with Kentucky's fact. We heard Tate talk this morning about the implementation of performance testing. So what we're banking on is that with these binder grade bumps, the performance testing that you're going to see here in just a few minutes and everything that's required, that in turn we're trying to derive that pavement performance with these available binder grade bumps, and that's going to be made available to you, the contractor or the designer, to make that selection of whichever one you think is most appropriate. So anyway, this is total first 1 grade bump. A 2 grade bump is a 64E-22, the old 76-22 terminology that you're familiar with. That's what this would be. And in turn, you can use a 64E-22, one that you would have purchased for highway department work. That's viable, good to go. But then alternatively, you also can use a PG64S-22, just a straight 64-22 with aramid fibers at 4.2 ounces. Or you would have the option of using 64-22 with the engineered crumb rubber at 10% by weight of total binder. And this is a dry process rubber too, it's not wet process. So there's a couple of sources on that, so that would give you an option. And it typically is fed in at the wrap collar, so it's viable to do it that way. By the way, as we get through this presentation, I'll try to leave some minutes on the tail end. If you have any questions, if you would hold them to the end, and we'll try to address any questions you might have. 3-grade bump option, which would have been roughly the equivalent of an 82 minus 22, using legacy terminology. And you can go with an SBS modified with a 75% recovery criteria on it. That would, in effect, satisfy this criteria. But you're also allowed to use a 64E minus 22 using aramid fibers at 2.1 ounces, or the 64E minus 22 with crumb rubber used in there at 5% by weight. So that would give you the equivalent performance for a 3-grade bump option. And again, those options are in your all's hands on however you want to make that selection. Our notes, when you get to these jobs and everything, the special notes that would go with these, they would be provided in a proposal, so you would have those available. But as far as like on the aramid fibers, there's a special note for fiber reinforcement of asphalt. That's one of the reference notes on aramid fibers. And the other one is that the Virginia DOT has just put out a special provision for ground tire rubber modified surface course, and those are the sections in it. Again, that would be provided, but it's a very detailed written process or specification for the use of engineered crumb rubber used in the dry process. And so that's what you would have. That's very different from anything you would have seen so far. So anyway, that's one of the more biggies of this specification that got dropped in. There's also on if you're familiar with P401, P403, if you're using a 76 minus 22, there's a 75% elastic recovery parameter requirement on it. In variance with this one, where we're using MSCR testing, it would be a 64E minus 22 with 60% minimum percent recovery. That would be part of the MSCR test criteria. Anti-stripping additives, if it's required to hit the moisture damage susceptibility criteria, you have to use a liquid anti-stripping additive. When you put liquid anti-stripping additives in, typically at 0.3 of at least 0.5% dosage rate, you can see that it softens original DSR values. In some cases, if you had a marginal binder that was the lower part of that criteria, you drop in 0.5%, it might take you out of spec, take you below 1.00. So this is what this is all about in that statement. If it's on the presently the approved materials list by the Transportation Cabinet, it would be a viable product to use. We're going to go to Section 3, composition. In this one, this is a layout of the mixture, the lab accreditation, JMF, certified testing techs, and all the other issues, and allowable use of wrap, and then the control strip. So under the composition of mixtures, it just, quick overview, gloss through, it just talks about the requirements. I threw this up here, and I broke it down. I cleaned it up on the next slide, but anyway, basically the requirements for laboratory accreditation. And in this, if you're familiar with P401, P403 at present, it writes in the requirements that you have to have a laboratory that's ASTM-D 3666 compliant. And so what that means is that there's very few laboratories that do it. In all fairness, Bluegrass is, but in turn, we're trying to open it up into the industry to where there's more viable sources for testing available out there. And so what we've done is we've cleaned it up as such, is that the laboratory developing the JMF can be an AASHTO R18 compliant laboratory. And when you look at the fact that R18 labs right now, you've got, of course, Phil's lab, BAT, Bluegrass is R18 compliant. ATS's lab, I think, Keith, I think you guys, you're AASHTO accredited. E&B's lab is accredited. State lab is accredited. So there's R18 laboratories that are out there right now. And so with that would open up that opportunity for them to provide the testing they need for their own operations. And so that was a pickup there. The other thing is that what if you're not? What you can do if you're a contractor's lab and you're really digging your heels in, you want to do the mix design, you can contact an R18 laboratory and have them come and do a laboratory inspection of your facilities to ensure that all the materials or the testing equipment used in development of that JMF is in compliance with the test criteria that's required. And again, the reason for all this is that if we're trying to sell the FAA on the thoughts that we have a specification that addresses their concerns of control, of quality, and the test criteria, we have to go down this road to prove out the quality of our products, the test data that we're cranking out. The contractor's lab inspected by our 18 lab, daily, an inspection report to detail the results of that laboratory, and then in turn finally signed and stamped by a professional engineer in the end. For present P401, P403, ASTMD 3666, part of ASTMD 3666 is that on the testing technician criteria of the requirements, it's very stringent. So if you're not familiar with it, what it does is it details a certification and a records keeping process for all the technicians. And so how, in trying to address this new KDH spec, can we write something that's stringent enough that would satisfy the FAA criteria of 3666, but at the same time in the world that we live in? And so we've written it as such. And so under aggregate properties, if you're, you can either be an ASTMD 3666 compliant laboratory with that, or if your aggregate, all the data that you're getting has to be developed by a KYT certified aggregate technician. So if your aggregate supplier wants to do all the testing and they have a certified tech, great. If you're the mix designer and you're a certified aggregate technician, great. So anyway, you would have the viability to be able to provide all the data yourself. The job mix formula, again, if you're an ASTMD 3666 compliant accreditation, which would prove you as a technician, or the option that if you're a KYTC super paved mix design technologist, that would make you viable to submit that data as well. So again, that opens that door. Performance graded binder, all the binder suppliers, they have certified, nationally certified binder techs that are available to them, so the data that you would get from your binder supplier would satisfy that criteria, so you'd be good on that side. If you are a contractor's laboratory, or excuse me, contractor that's got its own storage tanks, bulk tanks, then in turn you're probably going to contact the Asphalt Institute or one of the other laboratories that are accredited, provide you certification on that, at least that lot anyway. The job mix formula, when you go down, this is just a listing of all the requirements for the JMF development. Initial approval before placement, all mixes designed with the gyratory, so there's no Marshall designs, everything's by gyratory. JMF should be submitted 30 days prior to paving. If the design is from a previous season, a 1-point check is required to re-verify, but if it's less than 1,000 tons, you can use that mixed design from that previous season, so you wouldn't have to have it re-verified if it's less than 1,000 tons. And the JMF has to be dated and signed by the super paved mixed design technologist of the lab developing the JMF. JMF shall include, of course, the binder certificate of analysis, anti-stripping additive COA, and on the certified aggregate test reports for your coarse and fine ag. If you're familiar with P401, P403, every time you submit a mix design, you had to have soundness, LA, and all the other test forms that are available that would go into the form. Those forms are still expected, but if you're getting the data from the Material Central Laboratory, if you get a printout from them, you can submit that for the mix design. That'll stand good. So that would take care of some concerns there. You also have the option to get that test data from an AASHTO R18 compliant lab, and there are some of those that exist here in Kentucky. Cold feed percentages, your combined JMF, specific gravity absorption of all your ags, your percent natural sand, percent fractured faces, flat and elongated, design binder content, gyrations, lab mixing and compaction temperature per Kentucky method 64-411. But if you are using a 64H minus 22, you're not going to see a reference then at that point in KYTC specs, so you're going to get that from your binder supplier. And then in turn, if on the 64E minus 22, if it's radically different than what KYTC says, you're probably going to want to supply that mix and compaction temperature as well. JMF plotted on 45 power chart, and then there's graphs for air voids, VMA, your max gravity, and your unit weight. The JMF also will have your TSR data, anti-stripping additive if you used it. Hydrated lime, nobody in the state of Kentucky uses hydrated lime, but as we're going down the performance testing rabbit hole, One thing you'll find is that hydrated lime brings something to the table well, it brings something to the table. I'll just leave y'all to develop that thought, but anyway, there's a lot that comes with hydrated lime. The KYCT index value for 5 specimens is required. And then the JMF has developed also Hamburg for 4 samples. And then if you're using wrap, you're going to see the wrap option here in just a second. Extracted AC, wet sieve gradation, and then your coarse and fine aggregate specific gravity on extracted, recovered wrap aggregate required if you're using it. When you get into the asphalt mix design criteria, we're going with 65 gyrations on everything. You got air voids allowed at 3 to 3.5. VMA, you'll see on the next table here on the gradations in just a minute. TSRs, 80% minimum. Saturations at 70 and 80, between 70 and 80, which is part of, again, P401, P403. That's what you're familiar with seeing right now. And then in turn on the Hamburg, 12.5 millimeter max rut depth. So a standard 64S minus 22 at 7,500 passes. A 64H minus 22, which would have been like a 7022, 15,000 passes. And then the 64E minus 22 would be a 20,000 passes. That's run at 50 degrees C. And then the KYCT index numbers at a 100 minimum. And it's all run at 25 degrees C. And it just gives you some of the test footnotes going to detail down here. One thing I will bring out is that at mixed design phase, it's required to report the long-term oven aging CT index values, and that would be 12 hours grand sum total. So we're trying to gather data on that. So that is required. It's just simply a report. There's no penalization for it, but it's something that is required to be reported.
Scott, I just thought, you don't have to move, man, unless you want to get 6 feet away from me. Social distance. The point on that, on the durability that Scott and I were talking about, was that, again, while it's data gathering out there, there's a lot of things that happen in the asphalt crude sources, and that's out of everybody's control, okay, out of the refiner's control. And so by doing the 8 hours, it allows us to have some insight on things, because durability is absolutely key. KYTC, as you're all looking at that, you know, you're not seeing the decline, different levels in the CT index, because we want to keep it one level for all of those, again, trying to keep durability at the top of what we're doing. So we picked a number and we chose 100. So thanks, Scott.
I think Nathan Moore is back there in the background, but Nathan, I think that the long-term oven aging represents what pavement performance or cracking potential jumping in at 5 years. I think that's what I understand. So in turn, that's one of the reasons it's something we're trying to address. When we look at the gradations of the mixes that are viable, if you're familiar again with P401, P403, what you're going to standardly see is you're going to see this gradation 1, which in this case we've defined to be the base course. Gradation 2 is the surface course, and that is the familiar 100% pass and a 3/4 with material retention beginning on the 1/2 inch. And so that would have you using like a 68, a 78, a 7, or something like that to hit the top size grading on that. Gradation 3, which when you look at P401, P403, is typically written in as a leveling course. This actually can be selected for the wearing course if KDA agrees to it. So in turn, that is written in as an option. Also, the equivalent of a number 4 or 4.75 millimeter is written in there as a leveling course too. You don't see that in the specs right now, or P401, P403, but that's a available option for the engineer to select if they want to use a leveling course. VMA criteria, which pans into the performance testing criteria. You'll notice that when you go back relative to KYTC familiar VMA criteria, you're 1% higher on VMA criteria. So that's going to be 0.2 to 0.3% additional binder content. So that's what that'll be. So that would help you on CT index numbers. When y'all stop to think about the grade bump options we were just talking with you about, if you're looking at an SBS modified 64E minus 22, in many cases, it increases some of the difficulties with passing the crack criteria. That additional binder content that comes in with the VMA bump right there would help on CT index. It would, to some degree. Lift thicknesses down here, well, these are the minimum asphalt contents for the mixes in question, and then the minimum lift thicknesses that you can see. And so you can see that, you know, you're coming up with sufficient lift thickness to address density as well. Wrap requirements. For base and shoulder surface, you're going to be allowed 0 to 20% wrap. There's no change in the binder grade if you're using 0 to 20%. 20 to 30% wrap, you're going to bump on both on the high side and the low side, one binder bump. So if you had 64 S minus 22 call for and you came in with 30 or 21 to 30% wrap, then in turn that should read 21, guys. Gary, I guess we would need cleaned up. That should say 21 probably. But we would do a binder bump to 58 S minus 28. Here's an option you don't have available right now in P401, P403. We actually built in a wrap option on the mainline surface at 0 to 15%. There's no change in the virgin asphalt binder grade. One of the things in trying to address that relative to the angst that probably the FAA might have is with performance testing, because some of the concerns about cracking potentially being an issue, we've got that built into the numbers, and we're gonna be talking through the spec limits, the pay factors here shortly, and you'll see where that comes into play. But we've got a protection mechanism on that side, but you do have the option to use wrap in the mainline surface if you want to. RAS, you're not gonna use RAS. Control strip. A control strip is required, but a control strip, you won't submit place a control strip until after the contractor's quality control program has been accepted in writing. So you've written it, submitted it to the engineer, it's been accepted, then you're going to be allowed to go ahead and do the control strip at that point. Control strip will consist of at least 250 tons or a half sublot. I'll say it here again, I'll say it a couple other times. An entire lot is 2,000 tons, each sublot is 500 tons. That's what it's going to be. Cold joint must be cut back. That is a general thought and concept. It would be up to the engineer to make the decision if that doesn't play, but as part of the specification, that is written into play there. So the test strip is acceptable if the gradation, asphalt content, and VMA are within the action limits that we're going to see back here in this back section. Mat density, air voids, joint density, KYCT index, and Hamburg testing meet the minimum requirements of section 6.2. If it's not acceptable, you make necessary adjustments and place another test strip, which is, you're familiar with the process of P401, P403, that's the game that you normally get into. If you've got less than 1,000 ton, control strip is not required unless there's some unique conditions that would have the engineer making that requirement, and I'm sure they'll make you aware of that in advance. Let's get into section 4. And Phil, again, jump in anytime you want to, big guy.
I will on the density when we
Yeah.
keep going.
Okay. Under the construction methods, let's talk about the various items, and we're going to get into each one of these really quick here. So under weather limitations, these are ones that are familiar with out of P401, P403, so there's no variations that you're not familiar with at present on that. Asphalt plant. Most of these sections through this section 4 are ones that are drafted pretty much for the most part out of P401, P403 as they're presently written. So again, there's no surprise because I think everybody's looked at those specifications to have some decent degree of familiarity with them. Storage bins, mix and storage shall meet the same requirements as the mix loaded directly in the trucks. Mix should not be stored greater than 12 hours. And for those that are familiar, as we talk about performance testing, specifically about the crack testing, storage time to any significant degree can have a very negative effect on the ideal CT index or KYCT index value. So, you would be very sensitive to that. So if the engineer determines excess oxidation in temporary storage is a problem, then temporary storage should not be allowed. Construction methods is this basically gives you an idea on your aggregate stockpile construction, methodology and management, no intermingling, and good management of your stockpile construction. Hauling equipment, trucks shall have tight, clean, smooth metal beds, light coating of an approved spray, no petroleum products used, and then tarps required. MTV, required for runway taxiway construction on pavements designed for aircrafts greater than 100,000 pounds. And Gary Sharp had a strong hand in this one. He contributed Major League to this. Recommended for all pavements where the weight of the MTV will not damage pavement structure. Use of the MTV is optional for shoulder constructions. So prior to the use of the MTV, the contractor is going to come up with a fully loaded weight of the MTV, submit that to the engineer. Then the engineer is going to examine that in light of the pavement structure that's been designed for that weight of aircraft for this particular airfield pavement. to make the decision whether the MTV is going to be permitted or not. So that is some initial information that's required. Asphalt pavers, this is just a roller sufficient number and type. It's again at the contractor's option to whichever he wants to use or to his best option. Density device, you can use nuke or electric capacitance, electromagnetic. You can use either one as long as you know you can use those thoroughly, accurately. Qualified tech is it's supposed to be there to operate the gauge and obtain density development. The test results are supplied to the engineer upon request. So he would have, the engineer would have the right to come up and just examine, look at your notebook and just to judge values. Preparation of the binder on unmodified binders should not exceed 325, and on modified binders not above 350. Preparation of mineral aggregate, you shouldn't exceed 350. Preparation of asphalt mix, basically just requirements that uniform coating, at least 95% coated particles, moisture contents under 0.5%. The application of prime and tack coats, accordance with Kentucky Method Standard Specs 406. Tack applied to all horizontal and vertical surfaces before placement of the next lift. So if you're cutting back joints, you're going to for sure want to spray that vertical face on a cut joint. Laydown and transportation, placing and finishing. Prior to placement, contractors shall develop a laydown plan, and which will detail sequence of paving the lanes, location of temporary ramps, laydown temps, estimated time of completion for each portion of the work, and it must be approved by the engineer prior to beginning the process. And again, I think we're all familiar with, especially under percent within a limit specification, that is we're trying to get uniform densities, just-in-time delivery or very well-scheduled delivery of the asphalt mix to the job site, and then in turn not having trucks piled up or running to where we run out of trucks. So it's just a continuous supply of material coming to the job site. Even though we don't have percent within limits, we're going to use range limits. That's what you're going to see here in a second. Again, we wrote the specs to try to encourage that, but in turn, again, for some degree of control for the FAA and their concerns or their angst. Temperatures for ag and binder and HMA straight out of the KYTC's section 401. You'll see these numbers. Compaction of asphalt mix, sequence of rolling, types of rollers are at the contractor's discretion. Surface defects to be corrected at the contractor's expense. No skin patching allowed. Joints, longitudinal joints exposed more than 4 hours, or the surface temp less than 175, or are regular damaged compacted, undercompacted joints should be cut back with a rolling wheel, minimum of 3 inches. So by that wording, echelon paving is allowed if you wanted to do echelon paving. So that way you would eliminate the cold joint question altogether if you had that as an option. Clean cut surfaces will be tacked prior to the placement of the additional fresh mat of the mix. Saw cut grooving, if you're showing it on the plans, it's in accordance with the FAA item P621. And Gary, I think as we discussed it, as far as saw cut grooving, typically not for the most part that we're familiar with. Diamond grinding is to correct surface irregularities. Diamond grind surfaces shall have a treatment applied per KYTC standard spec section 405 using a silica sand. There's in that requirements, it's got some sort of a high insoluble residue sand, natural sands, mortar sand, something like that. Nighttime paving requirements, contractor will submit a lighting plan to the engineer prior to beginning the process and have it approved. When we look at the quality control testing, section 5, this is an overview. I know we're going to jump into the sections right now. So under the contractor quality control, contractor shall develop a contractor quality control program. QCP shall be submitted to the engineer and approved prior to placement of any mix. No payment in excess for the contractor quality control program is allowed. For those of you who have looked at since, I guess, January of 2019 when the new FAA spec rolled out, C100 was the requirements for writing a quality control plan. And what you would see, and I've written several of them, is that in many cases that specification is very vague. There's a lot of ambiguity in the specifications. So what we did is in this section 5, when you look at it, it's a bullet list. Very detailed, very specific. Guys, y'all can go down this list, write put the necessary information that's required, it's going to be pretty easy to follow. So some of the angst that goes into writing a quality control plan, we cleaned that up for you quite a bit. So in turn, you just follow the list and put the information in there, so that would be very easy for you to write. So we try to make sure we address that as well. Contractors' quality control facilities. If you look at the KYTC standards, section 401 for requirements for a plant lab, that's what you're going to see. Engineers will be allowed full access to the lab at all times. If the engineer notices deficiencies, he's going to give you that, make you aware of that in writing. And if the deficiencies are sufficient enough or sore enough, they have the opportunity to stop work until those deficiencies are corrected. Contractor QC testing. A lot is 2,000 tons. We're going to have 4 sublots at 500 tons. So in that testing of that material, you're going to have for contractors' quality control, you're going to have asphalt content, and so you're going to have a solvent extraction with full dust loss correction. So if you look at typical Kentucky methods, if we're all familiar with the gasoline extractions, I burned my eyebrows off a couple of times on some of those guys. We weren't doing dust loss correction. So there is, if you're using a solvent extraction for asphalt content, there will be a full dust loss correction on it. And you can look at AASHTO T164 method A, and then back there in the background by either using a high-speed centrifuge or a mineral aggregate, mineral matter correction factor. Those are the options that are available. You can use ignition oven. So the correction factors would be established at the mix design phase, and you're going to provide that information in your mix design report. That's what you would do. Performed for each sublot. So if a typical P401, P403, you may be doing it, I think it's twice per lot. In this case, you're going to do it per sublot. That's what you would do. Gradation, twice per lot, and then wet sieve analysis. Contractor on the moisture ag, content of the ag once per day, typically in the morning prior to production. Moisture content of the asphalt mix once per day. Temperatures 4 times per day, and you're going to check that at the dryer, the asphalt binder storage tank, the asphalt mix at the plant. You can check it in the truck. And then the asphalt plant mix delivered at the job site. Contract on in-place density testing. Testing is needed to ensure density is being achieved. New density gauge or electromagnetic gauge. Surface smoothness. Again, these are things that came straight out of P401, P403 as they were written anyway, except for some of the blurbs on the density gauge. Smoothness, quarter, it has to be less than a 1/4 inch and 12 feet. You're going to measure for transverse measurements, longitudinal measurements, and any deviations greater than a 1/4 inch will be corrected with diamond grinding. Grade is evaluated, and it needs to be less than a 1/2 inch vertically and 0.1 feet laterally. Under sampling, any material, the contractor, or the engineer has the option that if any material appears inconsistent with similar material being placed, it can be resampled in the direction of the project engineer and retested if for some reason it's a large segregated area, whatever the case may be. So consistency is critical from that perspective. Control charts shall be maintained for individual measurements, for range, and posted in a location acceptable to the engineer. And they are to be kept current. When you look at the control chart limits for individual measurements, we're going to talk about this one in a second. When you look at this, these are the numbers that you see in play, and those, again, would be numbers that you're going to see coming out of P401, P403. But what you're going to see down here at the bottom, that for the action limits for a base mix, it's plus or minus 0.5% of the JMF. That's an action limit. For surface mix, it's going to be plus or minus 0.3% of the JMF. I know there will probably be a lot of discussion of that, but that was argued many times over, and there was a lot of passion in the development of that number right there. So in turn, that's what it would be for surface mix. When you look at the, VMA, at least 0.5% of the Table 2 minimum. Suspension limits, you can see those numbers. And again, down here, the base mix under asphalt content, 0.7 to negative 0.7 to plus 0.7 of your JMF. And then on surface mix, 0.5% plus or minus of your JMF. Suspension limits, for range, that's just the maximum and minimum between the upper and lower numbers. And those, if you're one hit the suspension limit, variation between 2 test results, you shut it off because you're judging it to be out of control. Corrective action, This is the definition of whether you're maintaining control of your process or not. So if you have one point that falls outside the suspension limit for an individual measurement on range, or 2 points in a row that fall outside the action limit for individual measurements, that would be a definition that, something, you're out of control, you need to take a reexamination of your process and reboot. QC reports, contractor will maintain and submit daily written reports of the QC activities to the engineer. So when we go to materials acceptance testing, we shall jump in. Acceptance testing will be performed at the engineer at no cost to the contractor. I guess, Gary, I think what we were talking about earlier is that if there's a thought that potentially the contractor's numbers could be used with examination by the engineer. Okay. Quality Assurance Testing Laboratory will be accredited in accordance with AASHTO R18. May utilize the contractor's testing lab if examination shows it to be in compliance. A lot size, again, is 2,000 tons, sublot 500 tons. Each sublot will be evaluated for air voids, VMA, KYCT index, and Hamburg. So we're talking about every 500 tons. A lot of testing, yes it will. But in turn, that's the valuation is on a 500-ton frequency. Samples are secured from the truck at the plant. Samples are randomly selected by location. And samples for the KYCT are to be short-term conditioned for 2 hours after sampling. And then in turn, 30 minutes in the 30 minutes in weighing and bulking and 30 minutes in the bath. It's kind of what we're familiar with on our experimental note, same process, okay? Hamburg wheel track testing, tested at 50 degrees C. In-place density testing, the exact word is a minimum 4-inch diameter core. 6-inch cores are preferable, but in turn, you do have the option to use 4-inch core if you want to. So, but in turn, that's at your discretion. Percent compaction is based on percent of maximum theoretical density for that sublot. Matted density is evaluated 1 core per sublot. Joint density is evaluated 1 core per sublot. Joint core is required to be cut with core centered on the joint. So that is one that in many cases of all my years of working on airfield pavements, that guy right there is what happens a lot of times is that contractor talks to the engineer backs away from the table, and they cut it off, centered off the joint, not cut it on the joint. And that is one of our weaknesses, is joint density. So the way this thing is written is the joint core is required to be cut with the joint, or the core centered on the joint. Thickness measured for each core extracted for density. The tolerance shall be within 1/4 inch of the required plan thickness. This is on in-place density and bond. If by the engineer's discretion, best determination, if the bond of the new mix to the underlying course is in question, to evaluate bond strength by the West Virginia DOT test method. So I don't know how many of y'all have seen bond strength testing. We do bond strength testing in our lab, and we have done now for several years. There are a couple of different, the test method, there's an ASTM test method that's a little more stringent, that's got a very slow rate of plat movement, and then there's the West Virginia test method that most people are using, and so this is the one we've referenced. It uses, in fact, your Pine 850 brake press. With one of these brake heads, you can use it in the throat of your Pine 850 brake press, and you can use that. So if you wanted to spend the money, you can get, in fact, let me show you the brake heads here, I think. This is an example of one. In fact, the gentleman who works in the West Virginia DOT's Material Central Lab, I think he's the machine shop. He makes these guys right here. And the slick thing about this one, this is a 6-inch diameter core, but it's got a hinge system on it. So as far as ease of use and speed of use, this is the best one we have seen right here. And that we got that from the West Virginia DOT's machine shop guy. The alternative is, I'll show you, this is actually the Carol Warner head. If you contacted Instrotech, you can get this from Instrotech today, and you can get the sleeves where you can do both 4-inch cores and 6-inch cores. The West Virginia brake head will only do 6-inch cores. But anyway, it's pretty easy to use. And once your specimen is loaded up, it's put in the throat of the 850 brake press. The specimen is broken. And then based off the maximum load and the cross-sectional area of the specimen, you calculate strength. And it's about that simple. And in turn, what we're looking at right now. In fact, we're looking at a 150 PSI minimum. That's the standard West Virginia number. It's 150 PSI minimum bond strength. So that's out there. So if there's a question of bond, that should be looked at. If you want to buy the Instrotech brakehead, you can get that any day, all day long. And you could do bond strength testing in your all's laboratory too. So would probably encourage you to take a look at it. Under material acceptance, acceptance is based on implementation of the quality control program. Air voids, asphalt content, VMA, mat density, joint density, KYCT index, and Hamburg wheel track testing, and then the finished grade. When you look at the acceptance limits, low limit for air voids is 2.5, high limit's 4.5. For asphalt content, again, we're looking at 0.5% of the JMF for the minimum, 0.3 for the surface, and then 0.5% on the high side for base, for max, 0.3 for surface. When you look at the VMA minimums, if you go back to that gradation band that I told you earlier where we identified all the mixes, the VMA criteria is down at the bottom of that table, and so it'd have to be at least the minimum VMA. Mat density, low side is 93% of solid, high side 97.5, joint density is 90.5, and then KYCT index minimum is 100. Hamburg on wheel tracking testing, a 64 S22 is at 7,500 passes, a 64H at 15,000, and a 64E at 20,000 passes. Grade, you're going to look at it and verify if it's within a 1/2 inch vertically and a 1/10 or a 1/10 of a foot laterally. You're going to have the survey from that pavement signed by your licensed surveyor too. Resampling pavement for mat and joint density. So within 48 hours of being notified of some materials that are deficient, on 1 core per lot for mat and joint density, you have the option to retest, but those results would be averaged with the previous results to establish a new average. Leveling course produced within the action and suspension limits on gradation and asphalt content. We will report air voids and VMA, but there's no mat or joint density. Method of payment, we're going to talk about this real quick. Measurement of payment is by tons and cutting of coal joints. So under, what do I just do? All right. The pavement for the lot will be asphalt content, air voids, VMA, mat density, joint density, KYCT, and Hamburg. And then the payment for the lot won't exceed 100%, but calculated bonus from one lot can be used to offset a deficit or a deduct in another lot. So you can carry that forward so that the bonus will at least show up in that sense anyway, which would help offset any penalties. Price that you get is for all compensation for furnished materials, prep, placing, labor, tools, and incidentals. Now, I am going to break this. This is the pay table. And luckily, since I can't even see it, I've got a much better section of it. So when you look at the weighting of the pay factors, asphalt content's at 10, air voids at 10, VMA at 5. There was discussion of eliminating, but after further thought, we got VMA at 5. Lane density or mat density is at 20, joint density at 20, ideal CT or KYCT index is at 20, and then Hamburg's at 15%. The pay factors, as you can see, on asphalt content for the base, is if you go down and you exceed 0.5%, you go down a 10% hit on that. So you definitely are going to want to pay attention to achieving the asphalt content targets. And on the surface, there's some teeth in it, guys. So if you drop outside that 0.3 range, you're going to go to a 90% pay factor. So attention to detail and maintaining asphalt content. And as we're aware, if you're all watching, and we have been doing performance testing now for a few years, when you see the asphalt content on the low side, you'll see CT index values, start to go down quite a bit and everything. So we have to be critically aware of our asphalt contents and how it plays in our performance testing. Air voids, you are allowed, back up here. You are allowed bonus pay on air voids. So you can get 103% on that, and it gives you the criteria there. VMA criteria there. And again, on asphalt content below the specified minimum, if you get down below, you're below the specified minimum, it starts dropping off, at a reasonable degree. But again, it's only a 5% contribution to your overall pay factor. Mat density, these are the numbers that are laid out for that from 93.0 to 97.5, so 100%. Then if you drop below that, you go into a 95% pay factor. If you go down to 91.0 to 91.9, you drop into an 85% pay factor. In fact, for a 95% pay factor, 97.5 to 98%, you get a 95% pay factor on the upside. But if you drop outside those ranges, then in turn it goes into footnote 1, which basically either, it's remove and replace, or you have the opportunity after talking with the engineer to resolve that and get paid 50%. So again, teeth in that criteria. Joint density, 100% on, as you can see, at 90.5. If you drop below that, you start getting into deducts. KYCT index numbers. This is a point of discussion. So for 100% pay in the range of 100 to 149, for all the, if you're in excess of 150, you're going to get 103% on CT index numbers. So they want to control the cracking, we want performance, and you're going to be paid from it from that perspective. What we have seen in talking with many of you guys, what we see standardly during production testing is that in many cases the CT index numbers from our laboratory mix design phase, we have an established number, somewhat lower. Then we go into production testing. In many cases, that production testing is quite a bit higher than laboratory mix design phase. And so if you're in excess of 150, you would have the opportunity to pick up bonus pay on CT index testing. So anyway, that was written into it. But then in turn, on the negative side, if you start dropping off and you go into below 100, 71 to 99, you're at an 85% pay factor. And if you drop off less than 70, that's when you go into footnote 1 category. The Hamburg is 100% pay, at least at the specified minimum or more. And then in turn, you go into the deducts as you go into the number of passes that don't satisfy the criteria. Did you have a question on density?
No, just kind of just a general comment. Watch our time. Okay. Nice job, Scott. So I just wanted to add, guys, when you look at this, Gary, I believe, in work as we work with different states, there's nothing out there like this, folks. This is a state-of-the-art specification. We also know, being a game changer, that we got to put some trial projects down. So as we do that with you guys, it's going to be really important we get the feedback. It's got a lot of bite in it. When you look at the ideal CT, where it's elevated up there, and we know it's not all the way up where it could be maybe for the in place, but what happens is we got to walk before we run. So if you silo, heat and ideal CT, they're not friends. So if you go and silo this mixture, rains or whatever happens, and you're delayed 4 or 5 hours, and you put that mix down, you better be checking that ideal CT first, because you could find out that mixture has now aged. All a silo is a big oven. So pay attention to what happens in those processes. The goal is to get something that's consistent, something that's durable, best practices. At the same time, 93% density is really high compared to what we would normally do. We also know that 1% addition in density can lead to another year to 2 years pavement life on a regular asphalt pavement we'd have on a highway, probably 2, maybe 3 years on an airport pavement, as been looked at by federal highways anyway. But you can't get to 93 without the give and take. And so it was a lot of thought went into making sure that we get that thickness where it needs to be. We can make Scott and I can do a lot of good designs, but unless it's constructed right, and we got to construct it without breaking the rock, that's going to be really important. So we get all these down, Gary. Hopefully, we're going to have something that lasts long and is good for the aviation guys.
Gary's going to have a point here. I was going to say one more thing. That relative to the 93% density, that 1% higher VMA criteria, the extra 2 to 3/10% binder content, that will play very positively in the ability to get that density. I'll tell you what, Timmy, just a second. I think Gary had one last thing to say, and I'll grab your question. The guy.
Scott, I want to make a comment or two, just a comment about this. Yeah, I did my best to keep my mouth shut, but I just couldn't at the end. Just a comment about this specification, just in general. it's still a work in progress. I mean, you've seen there's been a lot of development, and we've put a lot of effort into it. Our goal now is to get this thing out on the street with some trial projects. Again, we mentioned earlier, we're thinking the number of trial projects is still to be determined. That's a function of budget. The minimum we'd like to see would be 3 that would be out there, maybe 1 regionally, west, east, and central. We'd really like to see 6 or 7 if we could. That would, the KDA's broken. When they look at internally, they look at they've got a number of their airports are broken into like 6 or 7 regions. So we'd like to get that into those. But this is still a work in progress. And as we move forward, obviously one of the things, this is still a partnership. So we need to get feedback from the industry in terms of, will this work? So that's just a comment I wanted to make. It's a work in progress. We need to have a partnership here, but I think you can see that these guys have done a tremendous job in terms of the heavy lifting. But now, again, and in thinking about the FAA, it's not a requirement that we have the FAA to approve this. We can use it on state-funded projects. You saw yesterday there's budgetary items out there to fund work on GA airports, state-funded. Our goal, though, would be with some of the performance testing, would be that we could get the FAA to buy into that this is a different kind of mousetrap and something that they could buy into, at least on a trial basis for projects that would be federally funded. And that's something we'll be working with the KDA to try to work our way through that. Thus far, we have not actually presented this to the FAA. So we've had some conversations. They know that we're working on it. I've had some conversations with other state aviation departments, and they're interested. So again, just an added comment. Sorry, guys.
Jamie, you want to say something? No, I mean, I think the full implication test results, period. And so, obviously, but if you come up to a failure point, if you're with the frequency we were talking about, if for some reason there's a concern on a given sublot that you had a failure and you're continuing on down the pike and everything, so there's going to be a spot you may have to jump into. Yeah.
It's a draft, yeah. Tim, it's a good point. It's a draft spec. And right now through ASTM, the ideal RT test is going through another balloting, keeping our fingers crossed, seeing where that goes in the next 3 years. You could see that substituted in. We don't have anything to go off of yet.
Uh, 20,000 past Hamburg with all the necessary bills and Wilson's built into it. I think it's 8.1 hours. I think that's what it is. 8.1 hours is what it is. So that's the time frame. And of course, at 6422 it'd be 7,500 passes, but there's a time element. Relative to ideal RT, high temperature IDT is out there right now. If y'all do TSR testing in your laboratory and you got an oven you can set down to 50 degrees C, you can run high temperature IDT right now. And NCAT, that's what Alabama uses for their rutting surrogate. In fact, they dropped the APA out of that, and they're high temperature IDT for their rutting test right now, 20 PSI minimum. And so you can run that today if you need to as a surrogate test, but in terms, just whatever, digress. Any other questions? Timmy, fully respect your thoughts, my friend. I do. Well, with that, thank you we appreciate the opportunity to be here, guys. I think lunch is being served now.
Check. 1, 2, 3. 1, 2. Can everybody hear me? Way too loud. Let's turn it down. Okay.
They're gonna ask me to turn it up at some point.
What do we got now? 1, 2, 3. A little bit higher. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2. Let's just start with that. Okay. I think if it starts echoing like. One, two. Oh, I told you not to touch it. We already did this. Take it way back down. Way down. Wait, not that much. Whoa, what? I'd say about 1/3 of the way up. Hello? Does that work? Well, we can start there, I guess. That'll work. They want it up. Up? Oh, that's good. Are you sure?
It's louder in your head than it is out here.
It is? Oh, dang. Over here in the wings. So they're
okay.
watching on
Yep.
YouTube.
That's right.
Welcome back from lunch. Our first session this afternoon is on the 7 habits of highly effective producers. TJ Young is president of Technical Training and Advisory Services Company, or T2A SCO LLC, and that's pronounced TASCO. He has 40 years of experience in the asphalt industry, including 20 years working with 2 different plant manufacturers, 5 years working as a regional manager for a material producer, and since 2000 has served as full-time consultant to the industry. He also functions as production manager for Duval Asphalt in Jacksonville, Florida, while maintaining his consulting and training schedule. He is a frequent speaker to the industry for NAPA, World of Asphalt, ConExpo, ConAg, and for the statewide contractor associations. Please welcome TJ.
Thank you, man. Appreciate it. All right, do you want to kill this? Because we'll go with the lavalier. We're good? Everybody hear me? All right, great. You're going to key this up. Let's see if this thing works. And I suppose I got to turn it on. That helps. There we go. That works. Okie doke. Well, it's great. Wow. I'm not used to working in the spotlights. I really appreciate the chance to come back to Packy. You guys make me nervous every year. You've heard me say this before because they keep inviting me back for some reason. I'm not exactly sure why, but I really appreciate it. I have a fond kind of spot in my heart for Packy. You guys may not be aware of this, but this is one of the top 4 state association meetings every year. Brian's done a great job, and you only are in here, so you don't get to see what the other states are doing. And this is a really famous program, and it's an honor to be here again. And we talked this year about what we wanted to do, and Steve and I, and Steve's going to talk behind me on effective paving. He and I worked together down at Duval Asphalt, and he's also in charge of a group called Asphalt Testing Solutions and Engineering. In fact, we're opening a new binder lab on Thursday, and he and I have been making several presentations together along these topics, but because as a production manager at Duval, my responsibility is to make high quality mix and make sure the plants are online, our costs are under control, our pay factor from a plant standpoint is good. His background with the DOT, and now I'm doing your introduction, Steve, but for next session, so, if we run out of time. His background's in the field, being a district bituminous engineer in Florida. He's a really good field guy, and he's going to follow up with this talking about 7 habits of highly effective paving people. One of the booths out here is Stand Steels, and there's a guy that owns that company, and I know him as Lenny, and he knows me as Terry. And as we got older, he became Leonard Lesh, Mr. Leonard Lesh, and I became TJ because we had too many Jerrys and Garys and Terrys working in an organization. And when I was a young guy, like 40 years ago, when we were all kids together, we're about the same age, I remember him, I was his direct report. I mean, I reported to him. And he called me aside and he said, "This is something I want you to keep in mind. We're not any smarter than anybody else in the business." And he said, "The difference is that we get to travel more." And that always stuck with me. And that's kind of the hub of this presentation, really. We had the advantage. In fact, the culture there, when I was working with Charlie Grote, some of you guys know Charlie, and his son Charles III's out there at Reliable Asphalt. And Leonard is here at Standstill, owns Standstill, and me. We've still been in the business all these years, 40 years ago. The difference in that culture and that company, we all worked together at one point in time at Standard Havens, and the culture there was you couldn't check a bag, you got a travel bag when you went to work there, you got a credit card, and you were expected to be out of the office. When I left under Leonard's wing and went to work for Bob, he called me in one day and I said, "What am I supposed to do for you?" And he said, "You're supposed to be real smart. You tell me what you're going to do for me." And I'm like, "That's it? That's a job description?" "Oh, yeah. And the real world's outside. So if I catch you in the office very much, you're fired." So we were just supposed to go out and find out what was going on, what works, what doesn't work, and take that and bring it back into the company. What do contractors need? What ideas work best? What are the practices that work the most effectively? Okay? Well, fast forward, I start doing consulting work full-time in 2000, and I'm kind of in this, and I have a sneaking hunch, this is the program we're going to do next year. I was just on Napa subcommittee meeting 2 days ago, and we're reworking the energy management module that we did at Napa, that I was here and 2 years in a row presented that to you guys a number of years ago, is how to maximize your energy efficiency at your plant. With all this talk about, green and low carbon footprint and everything, that's kind of the trend right now. We're reworking those whole programs, and I spent a lot of time as a full-time consultant before I ended up getting sucked into Jurgensen's, and Duval Asphalt has got the Eaton, the Jurgensen family involved in that. So Eaton Asphalt, they're members here, Valley Asphalt up in Ohio, and there's a bunch of guys from that empire in this organization. And Paul actually has Duval Asphalt, and Paul and Jim are cousins, right? And so we kind of have ties into Kentucky, and Ohio. But when I was doing consulting work full time, I got hired because we do this energy management thing, and I went out and started doing a lot of plant audits. And so, I think I did over 150 just for the Colas Empire, okay? So these guys have multiple plants. So I've probably gone out and done performance audits on 700, at least 600 or 700 asphalt plants over the years. And part of that is energy management, which we're going to probably be talking about next year. But in part of that, it's like, well, how's your plant running? You know, how's everything doing? And, well, how's your mix quality? Okay? And so I started collecting information, and I discovered all sorts of stuff that I didn't know. Like 80% of all the drums the trunnions are screwed up on, you know, in North America. True to this day, right? And we over-lubricate exhaust fan bearings, and we burn them up on a regular basis. You know, you start learning all sorts of stuff. And like Leonard said, is when you start asking about mix quality, okay, I'm looking at your plant here, do you have any problems with your plant? No. What, you know, you start asking key questions, and you start finding people that are really performing at a high level. And we didn't know that. And we're building these plants, we're selling them to you guys, teaching you how to run them. We don't really know what's going on, right? And you start connecting the dots, because that was the culture that I was raised under, right? Connect the dots. Find the common mistakes, but find what works well. And when you start doing performance audits on these companies, there are companies that don't have failed samples, who have very little amount of rework that they have to go back and do, that are always performing at a very high level. And you start learning things, like he said, we're not that smart, we just travel more. You start learning things and seeing what these patterns are that people are successful, what they do. You know, I'm not a sports guy, and I don't tell good stories and good jokes, and I don't really know that much about sports. I was always the kid that got picked last, right, on the team. But you look at Brady, who just retired, and you look at the effort that he does and how he pours over those game films and the work that he puts into, is no wonder he's, you know, one of the better quarterbacks, right? I mean, he's got talent. Tim Tebow said, it's not just the talent, it's how hard you work, right? And so when you start lining up these companies that are successful and you start seeing a pattern, you go, wow, if I do those things, then I'll be successful too. It's simple. It's a simple concept. Steve's here because as district bituminous engineer in Florida, and one of the key guys in two of the districts down there, and we sucked him away from the Department of Transportation. He's out there looking at guys that are paving successfully and guys that are making the same mistakes all the time. And he's going to make a presentation on the guys that always win in the paving world. You know, these are the things they do. And so this has become a pretty popular presentation. There's a lot of states have asked for us to make this presentation. So what are that people do that are very, very successful? And this is what these items are that we discovered. Again, let me stress that we were not smart enough building plants and selling plants and everything to know what these things were until we got out there and started really digging and spending time with you guys. So these are the things that I've found that people that you compete with that don't have mistakes, that don't have a lot of redo, or if you're in an opportunity to make bonus, the ones that make bonus, these are the activities that they do that make them successful, okay? I'll sit here and try to turn my phone off. And with the idea being that, what are we going to do about it, right? So where we're going to go with this whole thing is you're going to have to make a decision when we go through these items for these next two presentations. It's like, what are you going to do? You know? If a professional golfer, my dad used to say he loved to golf, and he said, you can't be a good golfer, you don't play 2 games a week. And professional golfers are out there playing and playing and playing. Steve coaches baseball. He went to Alabama and played baseball for him, and and he'll back me up on this. You go to practice, you put the time in. You know, if you're a professional golfer, you're out there, you're hitting a lot of balls. I mean, these guys will go hit 1,000 balls, right? And that's what makes them good. They run the plays. They study the game plans. And then when they go to the playing field, they're winning. And our playing field is firing up the plant Monday morning, making a mix, giving it to a crew, and putting it down. So what are the things that your competitors do that are winning? So what are these 7 habits of highly effective producer? And here's the short list, and I'm going to skip over it because if I do that, if I tell you what those 7 key things are, you know, it'll be a boring presentation. Okay, so let's start with the first one. Again, let me tell you where we're going to go in the end with this. It's like, what are you going to do about it, right? What are you going to be as a manager? We're all managers. You know, how many guys do we have out here that are just plant foremen, you know, that just run a plant, okay? There's got to be some of them in the crowd there. You're managing your plant and the 3 or 4 people that work for you. If you got multiple plants, you're managing those 3 or 4 plants. If you're QC manager, you're managing these crews, these field technicians. You know, what are you going to do? And if you follow those activities, you're going to have success. It's a simple concept. Keeping equipment online, we do preventive maintenance. The end of the month, I'm going to Missouri. They want to talk about preventive maintenance in their training school. Well, you know what you do? You look underneath the hood, right? So if you check your tire pressure, you look underneath the hood, you're going to find stuff before you have a problem. And then all you got to do is look, find, fix, right? And then you're going to have success, and your equipment's going to keep running. You do these things for plants, and I promise you, what's going to happen is you're going to have success. You're going to have more success than you have now. Now, if we go through this presentation, we talk about these 7 habits, okay? And you go, I do all that. Then you should go away from here feeling good about yourself, right? Because it's like, I'm on top of my game. I'm doing the right stuff. And where this 7 habits came from, we stole it from Stephen Covey's book. It was a real popular book a number of years ago. You might have remembered it as 7 Habits of Highly Effective People. Then it was 7 Habits of Highly Effective Managers. So we just kind of ripped that title off from him. Okay, the first thing is know what's in your stockpiles. The people that have success know what's in the stockpiles, okay? Because the gradations are going to vary from the quarry, okay? Gradations are going to move. We have bands that we're allowed to operate in. Knowing what's in there, mapping your stockpiles. They actually will record data, like what we do is we'll sample our material at least every 1,000 tons. When we get over to wrap, when we're processing our wrap, we sample every 500 tons. We lay it up in a certain space. We have a spreadsheet. We know what that data is, and we know exactly what's in the pile, okay? This is a picture of a map in one of our yards that shows it has a date and it has those control sieves for that size stone, so we know what's in there. So when we are going to feed that material into the plant, we know what we're feeding into the plant, okay? Garbage in, garbage out. Good product in. You know, to make a good product, your plant has to be calibrated, and you have to know what you're feeding into the plant. FIFO versus LIFO is the best approach. Now, a lot of you guys are streaming. It's a large crowd. The room is huge. There's a huge echo. And is the sound still okay? Are you guys okay with the sound? Right? All right. So what does that mean? First in, first out versus last in, first out. You want to get in trouble? Make one pile, bring rock in while you're running the plant. Fresh rock goes in front of the bin. The guy picks it up with a loader and throws it in the plant. And then you wonder why the mix changed. Well, the rock changed, right? So the mix is going to change. So if you can have a left-hand, right side type layout, if you can do a front side, back side type layout, and if you look at your stockpile area and you really focus on this, you probably can figure out a way to do that, all right? It allows time for verification testing. So again, you know what you're putting into the plant. So separate those materials into cells. You know, not my idea, my observation. like Lennon said, I'm not smart enough to know this, but I see guys do that. Why do you do that? Well, now I know what I'm feeding in my plant. Duh. It's like, oh, that's a good idea. That works. So front and back, left and right, recharge a cell at a time, right? So there's a picture of the yard. This particular yard, they got a front side to the pile, a back side to the pile. They're documenting as the material's coming in. And there's a picture of the map. So if you want to focus on that a little bit more, you can see like the 78s, and it gives you date, and it gives you like that 1021, I think it says, 58, 59 on the 3/8 sieve. So we know what the control sieves are for these different aggregates, and we know we're okay or we're not okay. Use blend sheets. Then you use blend sheets to adjust your bin poles. Now, what they'll do is we use these blend sheets like you're seeing here when we do our mix design. Okay, if I go out and troubleshoot a plant, first thing I do is like, we're having a problem with gradation. I'm like, okay, why don't we sample what you're putting into the plant? Literally, I just did this a couple of days ago because we had a little hiccup. And so we just went out, Steve and I went out, I just grabbed some material right out of the feed bins, and I know what I think I'm putting in the plant. I know what my design called for, and I know what kind of my averages on these control sieves are. This is the first thing I do when I'm troubleshooting gradation problems. Are you feeding into the plant, and what's in that stockpile, is it what's on your blend sheet or not? Okay, and you know what? 80% of the time, the answer is no, that's your problem, right? So we use blend sheets when we establish our design. If the grades move on your plant, this is where you get gutsy. When the grades move on the stone, you're going to make a decision. And the guys that are good at this do this. They're like, well, the rock just went 4%, 5% coarse. I wonder if we ought to proactively make a move. I've got 20% of that rock, it's 20% of the feed. The grades just moved from the quarry inside the allowable tolerance band 6 percentage points. I'm going to make a +1, -1 adjustment to my feed bins. And when you do that, you start, and you have to do this a few times to get courage. You go, I can wait and watch my voids move, my AC move with my voids, and watch my grades move, or I can just decide it's going to move. Let's just make the change ahead of time. So again, think about that idea. If it hasn't crossed your mind already, think about it. That's why you come to these meetings. Again, not my idea, my observation, right? And so this is a wonderful tool that you can use if your grades do move going into your plant. You can proactively make a move. My point in this presentation is guys that have success, that always ring the bell, that always hit the brass bell, that always come home with the prize, they do this, all right? They do this. All right, now, the next thing is keep your plant calibrated. So we start with a gradation, okay, and we calibrate the plant. Now, in this audit procedure that I did years ago, I developed a question. And I can tell you what the answer is going to be, and we have a crowd here, and we've got to hit a target, and we got people streaming in, so I'm not going to ask you what the answer is, but I can tell you what the answer is 90% of the time, and this is the question. When do you calibrate your plant or check calibration? And the answer is 90% of the time in North America, well, we do it once a year and if we have a problem. So people will calibrate the plant at the beginning of the season, and then they think it's like voodoo asphalt, right? They don't want to touch it until they have a problem. Well, guess what? Calibrations shift because a plant is a machine. Machines wear out. That happens. It's no different than a truck, right? Calibrations are going to move. It's usually an electromechanical problem, okay? But people that are always winning the game verify that their plants are calibrated. They routinely check their calibrations. So when you find somebody that goes, well, we check our calibrations all the time, How often do they do it? Surprise, surprise, what I didn't know. But now I advocate for people, which is what I'm doing here. It's like, you want to have success, do what the people that are successful do. Okay? View the game, films over and over and over. Hit 1,000 balls. Okay? They will every 2 to 4 weeks check their plant calibrations. Everybody's like, oh, we don't have time for that. Yeah, you do. Because you've got, each feed bin's got a calibration. Each scale's got a calibration. A meter's got a calibration. It only takes 30 to 40 minutes to check a calibration, and checking ain't changing. And you got to work with QC when you do that. So the guys who are checking their calibration go, oh, holy crap, something moved. You know what's a common mistake in our industry? Across entire North America, which is primarily where I work, somebody throws a board in a cold feed bin, or a brick, or a big chunk of concrete or asphalt gets wedged into the sand bin. You guys know what I'm talking about, all right? And they open the gate up to get it out, to keep running. And nobody pays attention. This is a very common mistake. Nobody pays attention which pinhole that went in. They put it back where they think it belongs, and they're off by an inch. And that changes the calibration factor of the plant. And then heaven help you if you've got your plant control set to where it'll hold ton per hour regardless of what goes on. Because a lot of plants can be calibrated like that, all right? You have an option. Do you want to turn that on or turn it off? And that means you put in 250 ton an hour, it's going to run 250 ton an hour. And guess what happens? It says, oh, there's a whole lot more sand coming out of that bin. Well, I'm going too fast. And it slows everything down. So now all your calibrations move. Okay, so by routinely checking your calibration every 2 to 4 weeks, okay, which the guys that have success do, you go, holy crap, one of these feed bins changed. Call QC. Don't make a change, because they might have tweaked the mix to make up for the fact they don't know what happened, but we've got this gradation's off. So they've pulled some sand out and they've done something. You move that gate without working with QC, you've just screwed your mix the other direction, okay? So you call them up and go, hey, guess what I found out? My 3/8 bin is running too fast or too slow. Oh, and this is what you hear a lot of times. Well, that makes sense now. How'd that happen? Who knows? VFD, belts, gearbox, drag, friction, somebody pinned the gate in the wrong hole. It happens. So bank on that. Your calibrations are going to move. Think about not waiting till the mix is bad, but being proactive. So the whole thing here, this whole talk is proactive versus reactive. It's just like preventive maintenance. It's proactive versus reactive. You don't wait till the machine breaks down to go fix it. You know what's going to break, so you look at it, right? The same thing with making mix, right? Calibrations are going to shift. Gradations are going to shift. So you just monitor it. This is what the guys do that are successful, okay? It's usually an electrical mechanical problem, and it only takes 30 to 45 minutes to do a spot check. When are you going to do that? When you're on hold in the afternoon and they can't decide whether you're going to ship 2 more loads or not, or they can't decide if they want to make another 200 tons or not, and you're on hold for the rest of your life starting at 3 o'clock, right? You might not go home till 7 o'clock at night, right? And it's like, send me 1 more and hold the truck. And everybody's sitting around. Can't work on the plant because you don't dare take something apart, because the guy might call up and say, I need 3 more loads. And you don't have it in the silo, right? You're not getting good numbers. You're not getting good cutoffs. You're put on hold. That's the plant guy. I'm a plant geek. Listen, that's plant life. I mean, do I got a witness on that? How many people? Just raise your hand if you agree with that. Okay? You guys have, come on, you need to participate here. That's what happens. These guys up here are just laughing because they know exactly what I'm talking about. Am I right? Yeah, they're like reluctantly going, yeah, he's right. So that's when you have an opportunity to have, you're on the clock, there's nothing going on, you got a truck sitting there, you got a loader sitting there, you wonder what you're going to do. You can't tear the plant apart because you don't dare take something apart, right? Until you've got some elbow time to do it. Under emergency you will, but if you're smart, you're not going to take something apart. Because things that you take apart have a way of taking twice as long as putting back in than you plan. This should be a 30-minute repair, and the taper lock breaks, and then the head of the nut breaks off. And the next thing you're out there with a torch, it won't come off the shaft. So now you're heating it up, and it's like this should have been a one hour repair, and it's a 2.5 hour repair, right? So you don't want to make that move. So you have the time on your hand. That's the point. I didn't know this. I observed this. So now it's become my religion, not because I'm so smart, but because I saw the guys that win do this. All right, proactively is the key word. All right, so there's a picture of the calibration procedure. There's a truck parked in there. That truck's on hold. Slinger conveyor, it's no big deal. You can just turn on the calibration check on your plant. You don't have to save it. It's just you check your belt scale first. You make sure your belt scale's good. Boom, that's a 30-minute deal, 45-minute deal. Run a feeder, boom, 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 and it just plots the numbers, and you go, yeah, it's pretty much what I had in the computer. We're good. We're good. Now, next thing is you want to produce in long runs. Don't bounce between mixes rapidly. Why? Because it takes time with these drum mixer plants to level out, no matter what anybody tells you, right? You have to get your PID loops, which is the reaction time. You can't control that, okay? That's the manufacturer, the guys that set up your plant do that. So that's like if you're going to make a change, think about cruise control in a car, right? And so you're going too slow. Well, you don't want to hammer the accelerator, right? You want to ease into the fact that you're running about 3 miles an hour slow. That's what's called a process integral and what's the other word? It's a PID loop. So it's how much change do you want to make, over what period of time, and how rapidly do you want to ramp that change, right? That's all the guys that set up their plant computers. And I've had guys that, we build plants for a long time, and I know that you can do that internally. And I've operated plants where I've called the manufacturer and say, I need these PID loops tightened up, okay? Some of them, when they call for an AC change or a gradation change, they ease into it real slow. So in that period of time, that mix is not exactly right. So when you fire up, the other thing that happens is when you fire up a plant and you change rate, there's a big gas stream going on in that dryer. The big rock comes through for a reason. It's got more mass to it. The airstream's holding back the fines, okay? That's why you don't dare ship the first 10 tons of mix. It's going to be wrong, right? And it depends on how that plant got set up, the technician that you had. So there's a little bit of what I call magic mix on the front end and the back end of a mix change. So you want to minimize the amount of mix changes. You want to let that plant get leveled out, which is what we call it on the street. The other thing is you want to stagger your start times on different jobs, right? Guys that are successful do this. So, everybody wants a different mix, and they all want to start at 7 o'clock in the morning. Dude, you can only make one mix at a time, right? So if you stagger these times, okay, and you start with one mix and you fill a silo and you shift to the other mix and you fill the other silo, and then the guys come in and you drain the one silo, and then the other guys come in and you start loading them, and you're ahead of them like an hour, and you staggered these start and stop times. As they talk about truck management, this is what they talk about. And now that we're short of trucks and we don't have drivers for trucks and we can't get trucks, this is the management focus, is really focusing on our crew times and how we manage that plant. But from a mix quality standpoint, what you don't want to be doing is jackrabbiting back and forth, 2 loads of this, 2 loads of that, 2 loads of this, 2 loads of that. Because you know what you got? You got 2 loads of iffy mix here and 2 loads of iffy mix there, okay? So you want to fire it up, plan ahead, get a firm schedule, fill a silo, make a controlled change, minimize the amount of times that you change your mixes. So try to produce a silo at a time and make my religion, or the plants that I run, and I don't even like 100 tons, but I'm like, if they jack you up, I guarantee you, I want at least 100 tons a run. When we run, Steve and I run trial batches, we do 100 tons. I've walked off jobs. As a consultant, the guy goes, we're going to trial batch. We're going to run 40 tons of mix. I go, I'm going home. I mean, I've done that. I'm just like, there's no way this is going to be right. You're going to go in the cone. The cone's going to be bad. And then the last load up there, you expect it to be right? I mean, we need to make 80 ton minimum, right? We trash 2 and sample the third and make sure there's 2 on top of it, right? So 100 tons is minimum. What I prefer to see is a silo. I try to manage what I could. The problem is plant guys can't manage the whole company. They're being told what to do. You guys that are out there that are estimators, project planners, top management, you're the ones that have to create the culture where you look at your trucking, you stagger your times, understand the production limitations, right, and help manage that entire company. Because everybody in our nation, in our society, just likes to look at their own little thing. It's an I, it's me, right? And it's like, so the paving guy is only going to think about his one project. And that paving guy's going to only think it was one project. You got to have, and that gets us into trouble all the time when it talks to quality mix. So the guys who have success produce in long runs. And again, the PID loops are at play. They also don't jack their ton per hour up and down during the run. Got a lot of trucks, speed the plant up. What's always bothered me in my observation about our industry is that, and when I'm working with top management guys, I go, you got to understand a plant guy. A plant guy's total focus is don't get yelled at and don't make bad mix. So if you have trucks in the yard, you're going to get a phone call. If you make bad mix, you're going to get a phone call. So they start making all their adjustment to the lens of just make sure you don't get yelled at. When you overtruck a job, or you send the trucks out, have you noticed this? You send the trucks out 8 minutes apart so they can get in front of the paver, and you got 6 trucks on the road, and you send them out 8 minutes apart, and 4 of them come back at the same time. Have you noticed that? Okay, that's our industry. And the guys at the plant, what we got to keep them from doing is speed the production rate up. So they're like, oh, God, there's trucks in the yard. I'm going to get yelled at. He said, where's the mix? Where's the mix? Where's the mix? They're watching Fleet Watcher. Fleet Watcher's got a booth out here. We use that company. And they're like, where's the trucks? Where's the trucks? And the plant guys will go, whoa, right? So when you you increase your production rate, you've got that PID loop at play again. And you've also got baghouse fines instability, because it takes up to 40 minutes for the fines to go into the baghouse and then come back around. Yeah, it does. And so when you go from 100 to 200 ton an hour at the drop of a hat like that, and even with controls that don't allow you to do that, you know how you do it? You put another mix formula in the computer, and you call it a different name, but it's the same bin pulse, and you just make a mix change and change the production rate at the same time. And then the plant won't ramp up in production. It just goes boom, boom, like that, from 100 to 200 ton an hour. And your baghouse fines are coming back at 100 ton an hour. So you're going to be short on dust, your voids are going to go up, and you might be out of spec on your 200 SIP. And when you go from 200 to 100, or you go from 300 to 200, the opposite direction, the opposite thing happens. So we have to protect the 200s, because asphalt and 200s are a direct impact on voids, and voids are king. So you want to ramp up your production rate and ramp down your production rate to do what? Manage your gradation on your PID loops and manage your dust. And the guys that are always successful know to do this. That means you got to plan the work and not react. Steady running produces steady mixes. Okay, so if you want to take notes, you want to go home with a sound bite, that's one of the sound bites you want to go home with. Steady running, steady mixes. Okay? Temperature. The first step of field density is temperature control at the plant. And they let us make mix in spec range plus or minus 30 degrees. And those of you that are paving wizards know that when you move the paving temperature, the mix temperature going into the hopper, more than 15 degrees, you got to change your rolling pattern. And what Steve will be talking about, probably, is what I'm beginning to observe is that we need to, because field density and smoothness is so important in our world today, and in-place voids, whatever you want to call them, in-place voids, is so important. The first job is for those operators to control that temperature within 10 to 15 degrees. But I can't do that. Yes, you can. And you know how you can do that? You get the loader guy in the room, and you get the plant guy in the room, and I've done this many, many times. I usually travel with a $50 bill. And you put a $50 bill on the console and said, you feed out of the same part of the pile, and you control this, and you don't jackrabbit your production rate up and down, and you get into this run, and if you can hold that temperature within 10 degrees, you can take that $50 home, and you'll lose that $50 within 2 hours. It's doable, but we are allowed this tolerance range, and we don't focus. We need to focus. The guys that are successful focus on that temperature, okay? Why? So that we can have field success. Temperature influences the rolling pattern. Holding consistent temperature achieves consistent density. Very key point. Next thing is socket load the trucks. I call it socket load the trucks. So if you got square body trucks, we have proven to ourselves around the whole United States that if you load front, back, and middle, you're going to have more consistent gradation control. Okay? Why is that? Because if we were going to load mix out of the ceiling here right into the middle of this room, and we have no confined edges, the big rock's going to roll the outside all the way around. And what you do in a square body truck is you're basically loading into a corner. So when you load against the front, it can only roll one direction, and that's toward the empty side of the truck. And when you load against the back, the same thing happens. And then the last load has got a little socket that you get to load into. And even on 12.5 millimeter mixes, I have proven and had fights with so many companies about this, that we can improve the consistency of the tested gradation by just loading the trucks right. And when they do go front, back, and middle, and you make the truck back up, okay, they'll move about that far. I mean, I've threatened to fire more truck drivers than you can shake a stick at in multiple states and multiple companies. And I go, no, this is what we're going to do. And I'll just stand there and go, keep going, keep going, keep going, stop. Man, I've been doing this for 30 years. I know how to drive a truck. No, they want to drive a truck the easy way for them. And even on now you get into a 19 mil mix or a 25 mil mix or a 37 mil mix, it's going to make a big difference. But even on a 12.5 millimeter half-inch mix, you can improve the consistency of the mix. So if you improve the consistency of the mix in the truck, you improve the consistency of the mat, and you improve the consistency of the gradation, and you improve the consistency of the smoothness. So guys who ring the bell do this. They have a religion of making those trucks move and socket loading the trucks, okay? Last thing, make calculated mix changes. There is such a thing as a flyer sample, where it's like, who knows what happened? Now, where I've seen it is like 200 sometimes just magically disappear, or you get a whole wad of them. Clarence Richards likes to call this, he sells those easy flow meters and stuff, he likes to call these sags and surges, the Bagasse does, okay? But sometimes you can go out to a plant and you can open the screw conveyors and you can watch the dust coming back, and if they haven't got them designed right, run at the right speed, they don't have the pulsing right on the back, you can see a wad of dust come and disappear. A wad of dust come and disappear. And if your sample ends up in the silo at the disappear part, you're going to be short on 200. You sample the next load, it might be just fine, right? The number one peeve of plant guys to QC people is jackrabbiting the bin pulls around, okay? They get one bad sample and they make a change. One reason I like Steve, because he thinks the same way I do. Let's take another test and let's wait till we got 2 or 3 samples and look for a trend. Watch for a trend and then make the adjustment. Remember, gradations change, calibrations shift, okay? Or they say, shift happens on an airplane, you unload the shift happens, and so you make a calculated change and use your blend sheets, take your data and make an adjustment. Don't make rapid changes unless you're running a test batch. Wait for 2 or 3 samples. So there's your 7 habits of guys that always win on the production side. Okay? They know what's in those piles. There ain't no guess. They check their calibrations frequently. Most people won't touch them until their mix goes bad. So they are proactively managing their asset, their production. Okay? They produce in long runs, steady runs, don't jack the production rate up and down, try to do a silo at a time, control their temperature, which when you do that, it helps you control your temperature as well, right? And to field density, load their trucks properly, and they make calculated adjustments. And you'll see, when you do this, you'll start noticing, wow, the mix has gotten coarse, right? And you'll see 2 or 3 samples, and you can just go make an adjustment. 1%, 2% change, +1, -1, +2, -2, and it makes a change. This is what people do that are successful in the production realm. So now the question becomes, if you're doing that already, pat yourself on the back. It's not my idea. It's my observation, right? And if not, you come to this packing meeting, you invest 2 or 3 days out of every year. It's a great meeting. And when you're driving home tonight, you say to yourself, which one of those things am I going to try to improve on this year? Okay? When I do an annual review with the people that work for me, and I've unfortunately always had people that have had to work for me, and if it wasn't for customers and employees, we wouldn't have any trouble, right? But when I sit down and I go, okay, there's 3 things. I try to keep it simple. There's 3 things I want you to work on this year. Let's agree together what those 3 things are going to be for each person. I found that 5 or 6 is just not manageable. 3 is like, this is what I'm going to do better this year, right? You drive home today on the production side, think about that. If you're not doing these things, and other people that are successful are, and they're watching the game day films more than you are, when you're driving home, think about, am I going to tackle one of those things? I really appreciate the chance to make that presentation. It's open for questions. We got 10 minutes. I think Steve and I are probably going to let you out 10 minutes early because we kind of timed this. It's kind of a 45, 50-minute presentation. Anybody have any contributions to this? Any questions? You agree? You want to add to? You want to help me out here so I don't feel like I'm the lone, preacher or whatever? Confirm? Question? Contributions? Well, thanks. I appreciate the chance to be here.
Once again, thanks, TJ, for your wisdom there on some of these things that we all in this room know happens. So let's adjourn till 2:20. The exhibits are open. Thank you. This next session is going to cover the 7 habits of highly effective pavers. Considered the asphalt technical expert, Steve McReynolds brings over 20 years of industry knowledge as the Director of Operations for asphalt testing and solutions and engineering. As the District 5 bituminous coordinator and District 2 bituminous manager during his tenure with the Florida DOT, he is known for his consultative and technical advice, which provides strategic problem solving with a variety of solutions. His broad spectrum of construction knowledge, threshold engineering inspection, construction site environmental inspection, and CMEC certified concrete cylinder compression strength, and extensive application of project specification requirements makes him a valuable resource to ensure customers are always compliant with state and local government regulations. Let's welcome Steve.
Appreciate it. Can you hear me okay? Quite an introduction there. I think the marketing girl that sent that up, she's going to get a raise for making me look that good. So we're going to talk about 7 habits of pavers. Are they really habits? Is it routine? You know, nobody knows how long it takes to develop a habit, so I like to say it's routines. And like TJ had mentioned, these come from my observations. So my time with the Florida DOT, I got to see all kinds of paving crews, from the A crew to the B crew, the C crew, the D crew. So you learn. You go out there and you see this crew and what they do and what makes them successful. So when I joined the contractor crowd, when I went to work for Duval Asphalt first, as we were getting ATS going, that was my job to, hey, take those things that I've learned and let's try it here at Duval. And it's an ongoing process. So what we like to start out with our company is a lead tailgate meeting. And I'm sure everyone has them. You talk about safety, you talk about what you're going to do tonight. Well, we developed this sheet for a reason. We were making mistakes. We were putting down wrong mix, we had the wrong compaction equipment, all these kind of things. So we decided, as part of our tailgate meeting, we're going to record it. So if we spend a little time with this sheet, you can see, you know, of course, you got a date and what project you're on. And the very first thing is our compaction equipment, because there's nothing worse than showing up on a job, mainline DOT job, and you need two 12-ton rollers for rake down and a finish roller, and you got the parking lot guy's roller. You got a little 10-ton heister. You know, how am I going to get 94% density out here with this equipment? So we go through that part. How many rollers we got, who's operating them, what's our rolling pattern. Then we go down to who attended the meeting. We need to get everybody that's on that project in that meeting so we can talk through this stuff. We list those names. It's an Excel spreadsheet is what it is. Then we go further. We start talking about texture and segregation. Hey, we don't have a MTV tonight. We're paving from truck to hopper. So let's watch out for our segregation. Let's watch out for the texture of the mat. And we keep going. We need straight lines. We're going to string line this. We're going to use our joint matcher. All these little things that we have on this sheet came from us making mistakes. So we talk about it before we pave every day or every night. I know you've all made mistakes, and you know the big ones are the mix type. We've put down the wrong mix. We had to go mill it back up. It's very expensive. We've paved outside the project limits. In Florida, they do a lot of these traffic op jobs where they rebuild intersections, put turn lanes in, put new traffic lights, and you just pave in that intersection. Well, we've paved off the intersection, and you know the DOT says, thanks very much for this new asphalt. So we try not to do that. At the end, we got a section for comments, so anything that's got us concerned, we want to go over those. And at the very bottom, we have an email list of who gets this sheet. And it goes to management. And in our company, it goes to the quality control manager, which is me, the operations manager, the project manager, and it goes to our vice president, which is, a big deal. He gets a copy of this every night. The key to this sheet is it needs to be commented on by the people that receive it. So if you're getting this sheet and you notice something, you need to make that comment back. As a manager, it's very important. Even if nothing's on there, just every now and again, you got to acknowledge that you're getting this sheet. Good job, or hey, did we get past this problem that you commented about? It's very important that you do feedback, because then it just becomes something that just gets written down, sent in. Nobody ever sees it, or nothing comes out of it. So in my mind, in our organization, this is a very important part of what makes us successful pavers. Next, we want to be mindful of our tack application. We want to make sure that that surface that we're going to tack is dry and it's clean. Number one thing for rework in our company is you got slip and pavement, and it happens a lot in Florida. We got to get that surface clean, and we're fortunate enough to have this lab that we can go out there and take cores, and we can look and pull those cores apart at the tack layer and find out exactly what happened. Was it clean? We didn't get it clean. Was it dry? Did we have water in there? We want to make sure that those tack bar tips are spraying uniformly. We need a good coverage of tack. Tack is very important. We don't need any cornrows or gaps or anything like that. We need that road tack. Is Kentucky, y'all an emulsion state? Y'all use AC for tack, or is it emulsion? Emulsion? Okay. So we want to make sure the rate is, we apply the proper rate. I know in Florida we use the emulsified rate, and some people take the water out of it and use the rate for the residual AC, the residual rate. But we need to make sure that we're following that. In Florida, tack is not a pay item. It's included in the bid of the bituminous. So for years it was a separate pay item, and you got paid by the tack separate, and you hardly ever had any tack problems. But when they took that away and they put it in the bituminous bid, then all of a sudden we had problems with slipping because we weren't quite getting that tack down. It's important. It's a very, very important part of paving, and especially with your density. So like you say, if you're using emulsion, we need to make sure it breaks. A lot of times our rework is done beginning joint. We tack, and everybody's standing there, you're wanting to pave, the trucks are showing up, but that emulsion is not broken right there at that joint. It's still, trying to cure, still trying to get the water evaporated out of it. But here we go. We set the paver down, we start paving. 3-4 days later, beginning joint shoved off the side of the road and laying in the ditch because we didn't let the tack break. It's very important to let that tack break. In these hand areas, if you're spraying hand areas, you want to make sure you don't overtack. It's going to take forever for it to break, and it also, if you get too much residual asphalt in there, it's going to bleed up through whatever you pave. Asphalt it does that. It comes up. If you have too much, it comes up to the top of the pavement. So we want to make sure that we don't overtack in those areas. So that, like I said before, the proper tack application can help with density. It's everything to me. If we got the proper tack, we let it break, we pave on it, our density is going to come a lot easier. Because I've done it where we've tried to get density without tack. People had some good ideas at one time that you don't need to tack on a milled surface because you have the striations that's going to hold the lift in there. So we did some of that. That's a research project when I was with the DOT, and you don't get as good density. Trust me. The tack helps get density. It's very important. So what else did I observe out there? The successful pavers, they manage those haul trucks. There's software out there available that you can put all your information in this spreadsheet, and it tells you how many trucks you're going to need. And I think it maybe over trucks it, maybe a truck, but it's a pretty good tool. I think Cat Paving has one. I know the Florida Asphalt Association, just like Packy, they have it on their website. to make sure that we got the proper amount of trucks to keep the paving train moving. We want to pave, just like TJ talked about with plant, steady run, we want steady paving. That's what creates a nice smooth mat, texture-free, or rough texture-free, and we get good density because we're just continuously putting it down, putting it down. Want to make sure we don't want to bump into the paver. Or even if you're using an MTV, it can cause some issues. But when that truck comes back and it hits that paver, you're going to put a knot in the mat, guaranteed. You want to have a good dump man. He's going to stop that truck. We're going to come with a paver, and we pick that truck up. Let the paver pick the truck up and go down the road. If you back that truck into the paver, it's going to make a knot in the mat, and you're not going to get your smoothness. You're going to go out there. We do a rolling straight edge job in Florida. We bump the mat. We make a knot in it. We got to go out and put a 100-foot patch in it, and it's very costly. Doesn't look good if you're trying to win one of those nice awards. Just doesn't look good with patches all in the surface course. We also want to charge the hopper swiftly. This is what I observed. These guys, they always had a good dump man, a guy with a lot of experience, and he's got a lot of responsibility taking the ticket, getting temperatures of the truck, but also with charging that hopper. And is a great technique is they raise the bed, they get it, they let that mix shift a little bit, and then unlock the tailgate, and then it all comes right out in the hopper. If we just trickle it in there, we get segregation. We can segregate that mix. The larger stone falls before the finer stone falls in that hopper. It shows up right on the mat. So we want to make sure that we're really charging the hopper correctly. We want to monitor the hopper and the screed. So in this hopper, and we're going to talk about it in our next presentation when we talk about segregation, we want to keep the hopper at least a third to two-thirds full at all times. So you can see the picture on the left, you got the slats showing, and on the right you got mix in the hopper. You don't want to do the picture on the left. What that's going to cause is you're going to get cold mix, segregated mix, down in, it's going to be taken back to the auger. It's going to show up right in the middle of the mat, and I think the catchphrase is end-of-load segregation or between truck segregation. It's a big topic in a lot of southern states right now. I don't know if it's been a big topic up here, but I know Florida took the time to write a spec that just deals with end-of-load segregation, and it's a very costly spec. If you have that on your project, what you have to go through to prove that it's not going to be bad is very expensive. And then if it is going to be bad, if the tests prove that it's not going to last, then you got to remove it and replace it. Again, 100-foot patches everywhere. So you can fold the wings. Some people say to avoid this, we're not going to fold the wings. You can fold the wings periodically. Make sure you have mix in there. Just keep that mix live. Keep the outside edges coming towards the middle. We put hot mix on top of it as we charge the hopper, and it all gets rehomogenized and goes back to the auger. We want to check your depth frequently of our mat. We got our little depth sticks. We want to make sure we're putting down that right thickness of our mat. With we got our roll down figured in there. We're maybe laying 2 inches, so we're putting down 1.25 inches. I forget what the rule of thumb is for most mixes, but you got some fluff in there because you got roll down. Make sure you keep checking that depth, and if we get off for whatever reason, and we're going to change our depth, we need to, the screed guys, they either need to use the toe point to raise that screed or the screws. Either one's fine. You can lower it, raise it, and get your height of your mix. But you don't want one guy using the toe point and one guy using the screw. We've had that happen. We've ruined some pretty good screeds on the back of the paver because this guy's raising the toe point, this guy's using the screw. We go the wrong way. Also, now we've twisted our screed. We've ruined a perfectly good screed. Or we put an invert in the mat, or we put a crown in the mat because we're not doing the same thing. So those guys on each side of that screed need to pay attention to what they're doing. Use them. Either one's fine, but use them one or the other. Don't use both, or one on each side. We want to continuously monitor for marks and drags. So you've always got to have a guy back there that knows to stop the paver if we got something in the mat and we're dragging. There's nothing worse than dragging a clinker, 100 feet down the road. You got to fill it all in by hand and fix those spots. So we need to monitor that mat all the time. Keep a constant head of material at the auger at all times. That helps us with our thickness, helps us keep the mix homogeneous, our texture, and it also helps us get density, which we got good texture, we got good thickness, we're going to get good density. So keep a close eye on that mat. So how these guys, they produce a quality mat, avoid excess looting. It's a part of paving, we're going to have to do it, but we avoid bumping the joint. I go out on paving jobs all the time, and for some reason we got a guy with a lute and he's just bumping the joint back on the mat for no reason. I don't know why. And you ask him why he's doing it, he goes, well, the guy I took over for, he always did it. So I guess he's just killing time, something to do. But we throw that back on the mat, the roller comes in and pushes all those big rocks and makes the mat look good. We got a texture issue. We don't want to backscatter material when we fix something. So if we find something in the mat that we need to dig out, take a shovel or take the end of that lute, get that right out, take a shovel of mix. We don't stand there and throw it halfway across the mat. We go over there, put it in. If it's in the middle of the mat where we can't reach it, put it here and push it there. We don't want to keep scattering mix. Another thing I see on paving crews is a guy with a shovel, for whatever reason, just getting mix and just throwing it on the mat. They didn't dig anything out, he's just throwing it on there. Why are you doing that? Well, God took over for it. He was always doing it, so I thought that's what I was supposed to do. I'm the shovel man. I'm shoveling asphalt. So we need to avoid those. Excess looting, backscattering material all the way across the mat. Let's just fix the area that needs to be fixed. Also, when we fix those areas and we lute it and we're satisfied that we got it fixed, we need to turn that lute over away from the spines and get those large rocks off of that mat. Just bring them over, get them off of the mat, discard them. We don't want to roll it in. It's going to cause a texture issue. The owner agency sees it and they think, well, we got some segregation here, when they can't recognize that we had a lute issue that we fixed according to the spec. But it looks bad. It looks bad in the mat. So let's get those big rocks and get them off. Those successful pavers, they do that. They get rid of them. Master the roller. So we need to ensure our pattern is keeping pace with the paver. So if the paver, if they got a surge of trucks and there they go, and your QC guy or whomever's back there, even the roller guys, if they're getting away from them where we can't get proper compaction, we need to say something. We need to say, hey, you need to slow down. We got to get compaction. If we get too much space between the paver and the rollers, the mat cools down, we're not going to get density. Temperature of the mat's everything. Monitor for mat pickup. Roller guys, they got to pay attention. Usually, if you're on a DOT job, you're running tandem, one guy watches the other guy's roller. Make sure we're not picking anything up on that wheel and making that mark every time that roller drum turns over. Boom, boom, boom. Marring the mat, making it look terrible. Use a proper technique to not create roller heads. I mean, everybody knows how to do that. We've been paving, pull the roller up, we come at an angle, stop, reverse our pattern. Always pull at an angle to avoid those roller heads. Roller heads that show up on a rolling straight edge, you can see them. It's just something that successful pavers avoid, is those roller heads. So we're going to prioritize quality control in our company. That's what we've done. We're going to monitor those edge lines for straightness. We're going to pull a string. We're going to pave on that string. We're going to use a joint matcher, whatever we have to. Straight edges makes better joints, especially at airport. You got joint density. You're never going to get density if that edge line is going like this. It's just hard to do. Lo and behold, somebody's going to put a core right in there where it is, where it's supposed to. If you're not cutting back the joint, a lot of airports would cut back the joints, but monitor the temperature of the incoming trucks. Like TJ said, they're working hard at the plant to make sure it's staying within 10 degrees. Isn't that your number? We want it right there in 10 degrees, 10, 15 degrees. So out there on the road, we're going to tell them if we're not getting our mix at 10 degrees, within 10 degrees. We get big spikes or big drops. It's going to make for texture issues on the mat. It's going to make us not achieve proper density. All kinds of things can happen when we drop temperature, especially texture and density. We want to monitor our spread rate frequently. Our QC guys, we do it every 100 tons. I think the spec is every 200 tons. You do the first five loads, which is 100 tons, and then every 10 loads thereafter, you do a spread rate. We do it every 5, just constantly. The level 2 guy up there by the paver, constantly monitoring the spread rate. It tells us a lot. It tells us where we're getting our thickness. And he's also looking at the mat constantly because he's doing his measures. He's watching the mat, all that stuff. If we're getting our thickness, we're going to get density, and we're going to be able to sell the job. So yeah, as we're doing the spread rate, we're monitoring for defects, pulls, tears, segregation, anything. First line of defense right there. We're going to obtain process control cores to ensure the rolling pattern is achieving density. So we got a non-nuclear PQI, pavement quality indicator here. It's telling us what our density is. We like to cut cores, so we take off. We let the paver get out there. We get our pattern going, and we'll cut 3 cores. Right, middle, left. We'll send those back to the lab. We either put them on a haul truck that's going back, or we had an extra body out there, put it in the truck, take it back to the lab, and check what we're getting for density. That way we know that our PQI is calibrated, but more importantly, we're getting density. It's 40% of the pay in Florida, so it's a pretty big deal. So based on those results from those cores, we'll adjust our rolling pattern if we need to. And this is every day. I mean, we might be going back to the same job, paving on the same surface, same mix, same depth, but again, every day we're going to use it. Things change with that mix at the plant. Gradation might shift. Might be a little harder to get density today. Might be a little easier to get density. I mean, it might seem strange, but in Florida, you get penalized for having too much density. They're working on that. They're getting rid of it, but it always amazed me. If you have too much density, then you get penalized for it. But so based on those cores, we're going to adjust our pattern if we need to, and also calibrate our gauges that we're using. We're going to check all the joints in the mat for smoothness with a manual rolling straight edge. Even if we're on a laser profilograph job where the lasers are going to run at the end by the department, we still pull the straight edge. Make sure it's smooth. Check all our joints, especially our starting joints. If we have to stop and take off and make another joint, we check them all with a manual, and then we run the whole surface with a rolling straight edge so that we're confident it's smooth before they run that laser profilograph. So these are the 3 important tools that successful pavers and the QC people have on the paving train with them. Very simple. You got a non-nuclear, you got a nuclear device. Either one works fine as long as you keep it calibrated, as long as you cut those PC cores, process control cores, compare it back to those gauges, make sure you can believe those numbers, and then also the temperature gun. Temperature of the surface of the mat. We check it behind the screed where it's coming out constantly. We check it, behind the rollers, monitor our temperature, make sure we're nice and consistent across the mat. A lot of times we can pick up segregation if we're cooler in the middle, by 30 or 40 or 50 degrees in the middle than we are to the outside of the mat. Pick up a segregation problem, get things stopped. Let's look at it. They used to be real expensive back in the day, but now you can get them at Lowe's. You can get them pretty much anywhere. They're $15, $20. Great tool to have. And I think, yeah, Florida even put it in there, that segregation spec that they wrote, they put it in there that you have to have one on the job. So I might have went through this a little fast. I don't think I used my 45 minutes or an hour, but let me leave you with this. Successful paving needs total buy-in from everyone. Everyone meaning from upper management all the way through the organization. We want to praise them loudly when deserved and provide constructive correction when needed. So as managers, we need to get involved in this. TJ's presentation with the plant, management needs to make sure that that's occurring, that's happening. We need to go out to the paving sites, look at our jobs, pat our people on the back, tell them what they're doing wrong. If you don't know, learn from them, you know. We got a lot of people who come into project management. They don't know anything about pavement, but they're good at selling jobs. They go out there and get us to work. But get those guys out there and let them learn. We've started a program at Duval Asphalt where any people that have potential to make management or that's their aspirations, we start them in the lab. We run them through mix design, quality control testing. We send them to the plant, learn the plant operations, learn the paving operations and all that, so they can learn the company as a whole so they know what they're looking at. But as managers, we can make this successful in the plant and at the roadway if we just pay attention, talk to our people, and keep that communication line up. So. Any questions or comments? I know I didn't take up too much of your time. I went through that pretty quick. I wasn't timing myself, but anyway, if you need any help with anything, I'm right there in Jacksonville. I think they're going to give you my information on your stuff that comes out of the thing. Give me a call. Talk to you over the phone. We can do a lot of stuff for you at ATS in Jacksonville. So we're proud of our, we got a new binder lab. TJ mentioned it, opening up next week, so we're proud of that aspect of it. And keep growing. Appreciate you having me up here to Kentucky. And let me tell you, I do have a connection with Kentucky. I meant to say that. So I'm not just a Florida guy. My grandfather and my dad both worked for the old Standard Oil of Kentucky before Chevron bought them out. They were stationed in Birmingham. They had a division office in Birmingham. So I got a little connection to Kentucky. So my first time here. It's a great city. Thanks, everyone.
I'd like to thank Steve. We'll adjourn and be back in here at, I think it's 3:40, I think. Thanks.
the lights were on, and I thought you might be home. I wasn't sure. For our last breakout session of the day, we're going to welcome back T.J. Young to present Way to Troubleshoot Segregation.
Come on, Steve. We're going to do me and Steve. Well, you know what? Not too many people left. I got some good news for you. Got some real good news for you. There is no way this presentation is going to last an hour. So you're going to get out early. Okay? So last one of the day. So a little bit of background on this one. We did some troubleshooting, I think. Got a troubleshooting program, troubleshooting mixes. We do one on troubleshooting gradation and one on troubleshooting asphalt content. And in that, we all know from experience, that if the mixes are coarse, you know, your AC usually drops. And if your mixes are finer, then the AC usually goes up, right? So usually, and I know there's an argument if they use the Bailey method properly, then this isn't going to happen to you. But in the real world, no matter where you are in North America, you're going to find that. So when we're looking at, you know, troubleshooting mixes, one of the things we look at is it consistent? So when the mix is sometimes coarse and sometimes fine, but sometimes okay, then you know you're stressing out. And the reason you're stressing out is because your voids are moving, your AC's moving, and you know, everything is like, what the heck's going on here? And it usually points to a segregation problem, all right? So in those programs, we talk about, well, you gotta make sure you don't have a segregation problem. Well, you know what the thing is in the real world? We all have, from time to time, unfortunately, a segregation problem. And it just drives us crazy. So in those programs, we start putting together, well, what are the things that we're going to look for? Now, Aztec has got a program they put together years ago that's troubleshooting segregation, causes and cures, I think they call it. And it's a wonderful document. And you unfold it, and there's a flow chart. But you know what? I was always pretty good in school. But I have a real problem with flow charts. You know, it's like you start here, it's like if this, then there, then you go here, and then you go there and go there. We took a little bit different approach to this in that troubleshooting program. It's like, just look here, 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 and here, right? Just look here, 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 here. We have a handout for you. And you're going to be able to download this handout. In fact, you go to the PACI website, get with Aaron, and get with everybody there and Brian. And this is the punch list stuff. You know, this is the place to look when you have a segregation problem. So we're going to lay these out down on here on the table, hard copy, because I've come to believe that it's real important that when you come sit through a program that's like, you got a takeaway. So what Steve and I are going to do on the first two programs we did, we're also going to put a simple bullet point checklist type thing that you can also download. Okay, just get with PACI and you'll be able to get that. You want a hard copy today, you can grab this dang thing, you can scan it in, put it on your own server, do whatever. And it gives you a place to look if you've got a problem. Okay, so let's just back up a minute. We all are going to have a segregation problem from time to time. We don't want to, but we do. If you're looking at it from a lab standpoint, then you're going to be looking at, like I already said, test results that are sometimes coarse and then sometimes fine. Steve and I are really chasing segregation. What I'll do is I'll pull like 2 or 3 samples like every other load. So if you're in a run and you're on a steady run and you're at a steady rate and you're doing everything we talked about and you pull 3 samples every other truck and you box them up and you run them, we all know that we pretty much expect they're going to be consistent, right? So they might be a little coarse, they might be a little fine, the AC might be off a little bit, but we don't expect them to be different load to load, right? That points to a segregation problem at the plant if you're testing mix, okay? So now what do I do? Well, what you're going to learn in this program is, based on the experience that we've had, it's like, look at these things, and now you got a checklist you can go by. So when we can get our skill set, our best practices, our troubleshooting, we can get that down to a punch list we can manage. Because we can give it to people and say, just go down the list. Think about when you buy an appliance, right? So my dryer went out the other day. You know, you go online, you go to the helpline, you look up your Whirlpool, whatever. It's like clothes don't heat. And they give you 5 things to look for. Well, it turned out to be the relay, right? But there's 3 parts that could probably cause that. Well, okay, I'm not a dryer expert, but I'm able to follow that list, and I'm able to get to the bottom of the $15 repair, right? And that's what it comes down to for us, and that's why we're here, is not only learning the skills that we need to perform in our business, but also how to get the other people to embrace those skills. Steve talked about like where those patterns become a habit. They become something that you really do. And also when things go wrong, how do we get them right quickly? And if we have a punch list, this kind of works out. So out of that presentations that we did, we sort of embellished this into its own talk, And I can promise you, because I've worked in every single state and every single province, and everybody's got this problem from time to time. So Steve, why don't you, he's one of the key things that tenants here that you're going to hear us speak, and you guys forgive us for repeating ourselves. You're going to find some slides here that almost repeat. But when you go to a speaking school, they tell you this. Tell them what you're going to tell them, and then tell them what you told them. Think about that when you go to church, okay, this week. It's called expository speaking, and they teach them, even in preaching school, that you want to have 3 points because people remember 3 things, and you want to repeat them 3 times. And you go, I've already heard that point, right? But that's what we've told them to do. So one of the key things that you're going to hear from us here is that our technique is real simple. Steve's going to start talking about segregation. Where are you going to see it first? In the road. You're going to see a problem with the mat. And the simple thing to do is just start working your way backwards. And segregation can actually be caused all the way back at the quarry, but you're going to see it in the road, okay? And when you see it in the road and you work your way backwards, so this is the concept that we're laying with you that we kind of tripped into a few years ago. If you just work your way backwards, where it stops is where your problem is. Okay? It's a real simple concept. Steve?
Thanks, TJ. Hear me okay? He's a lot taller than me. So segregation. So here's some pictures of some segregated mix. This is right in the wheel pass, starting to ravel up. It's a shame. The roadway's not that old. You can still see a lot of pigment in the pavement left. However, it's raveling up. Not a good thing. This is a picture of end-of-load segregation I spoke about earlier, or truck transfer segregation. So keep this picture in your mind, and I'll explain about this segregation, what causes it. Here's some more segregation, kind of across the mat. Might be a little dull, but you have coarse aggregate to the left, he's fine in the middle, coarse aggregate, just cross mat segregation. Here's some segregations, limestone in South Florida, and it's so bad segregated that when the rollers got on it, broke the rock. They got soft limestone down in South Florida, so bad segregated it broke the rock. Some more segregation, cross mat segregation, goes from coarse to fine, coarse to fine. This is up against a curb and gutter. So this is my example earlier when I talked about luting. Try to keep the luting down. It's segregated, yeah, but it's caused by luting. Made a repair up against a curb, but it draws attention. If you got a segregation problem and you have a lot of handwork, you just have more problems. It draws a lot of attention. So what we're going to talk about, segregation is common causes, inspection practices, prevention, what you do if you find it on your project, and we're going to talk a little bit at the end, TJ, is about clinkers and what they are. So common causes, and like TJ said, we want to chase the problem backwards. Unfortunately, it always should. We find it at the road because we don't have someone at the plant checking every truck that's leaving the plant. If we did, we'd find it before it ever hit the road, unless it's caused by the road. So the main reason that segregation occurs at the roadway is due to exposing the conveyors in the hopper, then folding the hopper wings. And I kind of talked about this before, my presentation before, is keeping that hopper a third to 2/3 full. If I get my hopper empty where my slats are showing, and I have mix in the outside of that hopper, it's cold. It's segregated, and it's cold. When I take those wings and I put that mix on those slats and drag it back to my auger, what's going to happen to it? It's cold, so the oil's not fluid. It's going to hit the auger, and it's going to come out right in the middle. And it's that chevron type design. If you look down the road, you can see it. Every time the guy folded his wings, which is between every load most of the time, he put that in there, and now we have this pattern going down the road. That's what end-of-load segregation is, and it's caused by the paver. Also at the road, cold mix. We're sending cold mix. It's important to get the temperatures right. Get it right at the plant. Get it right there. Cold mix will cause it to segregate. It will not go down the auger. It hangs up in the auger. It shows up in the middle of the mat. Some of it might be warmer than others. It'll move. The coarse stuff is here. The fine stuff's here. It's segregation. Cold mix really causes segregation. The screed angle. If we don't have the right screed angle, you can cause the mix to segregate. If we got too aggressive a screed angle, it'll take the mix and it'll drag it. It'll drop your depth and drag. Now we get big rocks showing, fine aggregates going down the road, coarse aggregates sitting right underneath the screed. Segregation from the screed angle. Equipment maintenance. That screed plate underneath there. If you pave with granite, I don't know if you do granite up here. We do granite in Florida and the South. Those screed plates wear out. They'll get holes in them. You got to check those things, and it will cause segregation. Mix will hang up in the holes in the screed plate. It'll segregate it. Also inside the hopper. The hopper gets some problems inside the hopper and cause segregation. Head of material at the auger. If we don't maintain that proper head of material, what's it, halfway up the auger height is where it needs to be. We get it too low, we can pull the mix. We get it too high, we can put too much mix in the road and segregate it. Anyway, that screed drags over what's coming through that auger can segregate it. It's not the right height. Overfed or starved screed. So we overfeed that screed, we put too much mix, it falls behind the auger, goes up under and gets rammed up underneath the screed. When other mix is going in there, that'll separate. Goes to the outside, we start dumping it to the outside from overfeeding the auger or the screed. Starving the screed too. We starve it, drags mix. We get too low, it drags the mix, segregates it. Failure to preheat the paver screed. This is a big one. It's happened to us. The guys get out there and they forget to preheat that paver screed, and then trucks are here. We gotta get the black stuff down. We take off with a cold screed. It just drags it and segregates the mix. Stopping the paver between trucks. So we don't balance our trucks right, and we stop, and we're not making the correct stop, which I think it's in the next slide. I'll explain it a little bit. If not, I'll come back and explain it. Then we can cause segregation there. The mix gets cold. Underneath the screed, we take back off. It drags the mix, segregates the mix. I think that's in prevention. So improper haul truck loading. So now we're going to the plant. I got my note here. TJ's going to take. He's the plant guy.
All right. So improper haul truck loading. We already talked about this earlier in presentation. I think a lot. How many of you guys were in the presentations earlier? Just show me some hands. Come on. Come on, come on, come on. All right, so we kind of already talked about this, right? So socket loading the trucks. If we're not loading the trucks right, these would be square body trucks. I don't think you guys use a lot of bottom dumps for paving, do you? Windrow paving? That's kind of a West Coast thing. I mean, they design those to where you can kind of load them in one load. But most of us are running square body trucks, and you want to load that properly. That could cause some segregation issues. Not major usually. It's mostly usually a texture issue when you see it out on the mat. It's like, man, this doesn't really look right. It's not like it's super bony, but it's kind of like bony and fine and bony and fine. So that can cause it. Malfunctioning batcher. And this is, again, what we want to talk about now is we're going to try to do a good presentation here, 80-20 rule. If I believe, based on all the experience that I've had around plants for all these years, when they say there's a problem with a plant, if it's segregation related, 80% of the time, 80% of the time, it's in the batcher. The other 15 to 20% of the time, where there are some other minor things that can happen. What we're going to focus on, the slides can come up a little bit, is build up in the mixing drum, okay? Build up in the mixing area of the plant, and it creates a dam in there. But most of the time, if I get a phone call or a guy calls me from the field, and this has happened 3 times in the last year and a half, I'm like, can you come up here and look? We got a problem. We can't figure it out. I can't come. What is it? Yeah, the last one I had was in West Virginia. And I said, he goes, I got a batch plant. I just got 1 silo. We're in wrap mix. We're starting to do this wrap mix. Now we got to say, I said, if you have this brand of how many silos you got? He goes, 1. I go, okay. I hope it's not this brand. He goes, it is. I tell you right now what it's doing. Go fix that, and your problem will probably go away. Another guy in Winnipeg, he calls up. He goes, I got a problem here. He had a bucket elevator mix. You know, I said, go to your outboard silo. Go through a couple transfer conveyors. Does the problem go away? Yeah, okay, now we can focus it down. But most of the time, it's a batcher problem. So the solenoid's not working right, the lubricator's hanging up, the cylinders aren't closing right, it's thrown a pin, it's sheared a key, and one of the gates is hanging open and the other one ain't hanging open. It's very easy to check. When we talk about prevention, I like everywhere where I've got some influence, I'm like, you go up and you make sure those batchers are working once per shift. Stand there and watch them. And don't just look at the cylinders move. The cylinders move a shaft. If it's thrown a key or broken the shaft, like in Ohio, I had a guy had an Aztec plant, and he has, like, I can't run coarse mixes out of this silo. I just go up, well, let me go up and look, right? Then I go up, and I said, just run the batchers. And I'm like, you know, your batcher's gate's broken inside. In an Aztec, you can't look inside the batchers. You can't look in there, you know. And that's the way they build them. And I said, you know, the cylinders are connected to one side, and it goes through, it's got a gate, you know, a shaft, and there's a bearing on the other side, right? So you don't look at the cylinders moving, you go to the other side and see if the shafts turn 90 degrees. One shaft's turning, the other one ain't. You got it's split in the middle, and one gate was hanging open. So he couldn't use that for coarse mixes. He would only put fine mixes in there, less likely to segregate. One of his was, it's 80% of the time, guys, I'm telling you, tell you story after story, it's batcher. If it's plant related, look at that batcher first, and then go from there, okay? Excessive slack conveyor rate. So what happens, this is a West Virginia guy, so what happens is if that slack conveyor is moving too fast, it can throw the mix to the far side of the discharge point, right? We've sat through quarry presentations, and we're putting aggregate on the ground, and you're doing it with a stacker. And what do they teach you? You go to CAT school. What do they teach you? The big coarse rock is going to be the end of the conveyor, and the fines are going to be underneath the conveyor, right? Because when you throw two materials of different masses at the same force, one of them will travel further, the heavier one. So it's inertia, right? So I build equipment for 20 years. In fact, I still build equipment. I just don't do it for a living. You buy a 400-ton-an-hour plant, I guarantee you're going to have a 450 or 475-ton-an-hour slack conveyor, okay? And if it's not put on a VFD, which now we sort of do because we can afford them, and they're pretty cost effective, and we save energy, but in the old days, if it's a constant speed motor, it's set up for 450 ton an hour. Now you put 250 ton an hour, which is pretty much what happens. So a guy buys 400 ton an hour plant so that he can run 300 ton an hour. That's what happens, owners, okay? And you guys do the same thing. You got a slack conveyor run 450 ton an hour. So that slack conveyor is whipping. And if you go at a low rate and it throws that material to the far side, it can segregate right at the end of the traverse conveyor. Now, if your batcher doesn't collect this right, then it can segregate right at that point. And that's what that guy's problem was in West Virginia. You get into, let's back up again. You get to open graded friction course type mixes, popcorn type mixes, or SMA mixes, boom, boom. This is a big deal. If you think this happens with those kind of mixes because they want to come apart. With SMA mixes, you load them up full of fines to try to fill in the gaps, right? Open graded friction course popcorn type mixes, you know, there are no fines, okay? So they want to come apart. And the way you can diagnose that if you think you got an issue, you do one side of your truck, you get a sample out of one side of your truck, and you get it out of the other side of the truck, and compare your test results on the same run, same load in the truck. And they don't match, this is what you're looking at, okay? So excessive slack conveyor rate's a big deal. Drum mixing drum buildup. You're gonna build up in any mixing drum, any drum mixer, Aztec double barrel, whatever, any mixing area is gonna build up, and you're gonna have to keep it clean, okay? That's fact. Nobody likes it. Nobody wants to do it. It's just a fact of life. How's that work? Well, it's cold. Oil sticks to it. Fines stick to it. You'll never find in that buildup big stones, right? You never do. Those of you that clean it, how many plant guys we got in a room? Just give me, come on. The less quickly you respond, the longer you have to sit here. I know you're one. So how many plant guys we got in the room? I see a bunch of them. Okay. Well, you know that the way this builds up is it's fines and oil, fines and oil, fines and oil. We call it oil in the Midwest here, but asphalt, cement, and fines, asphalt, cement, and fines. And it gets hard. It just cooks and cooks and cooks and cooks and cooks and cooks. Hards and builds up. When you get a lip going at the discharge point, because we've learned to design plants so they have a right angle discharge. So you don't want to go in line to discharge to a slack conveyor because the rotation of that drum can cause segregation in itself. So we always discharge at a 90. We learned that like when Charlie Grote was a young kid, right? So years and years ago. So what you've got is material has to go to zero to make the turn. From a velocity standpoint, it's moving down, and then it has to turn and make a right angle turn. There's a split second when it goes to zero, okay? Boom, turn, and it just starts packing in there. If you get a hump there, a lip right there, it creates a little dam. And then like the screed he was talking about, the material wants to roll up over the top, and it can't, and it actually segregates inside the mixing area. And you look real smart when you go out on a job and you find that issue and they're reporting segregation issues, and it's either showing up as a texture issue in the field or showing up in test results on the bench, and they go, I don't know what's going on. And you walk in, you just open the door, look inside their mixing area and say, see that hump right there? Yeah. Well, it's not very bad. It's 2.5 inches tall. Chip it out while it's warm. Okay, take 2 aspirin and see if your problem doesn't go away. And they're like, holy crap. What's going on here? You know, it doesn't take much to cause that problem. So 80-20 rule, the 2 when you want to look at, batcher first at the plant, batcher first, and then you want to look at the buildup in the mixing drum. Cross-contamination in feed bins can cause segregation. You know, if you get coarse material in the fine bin, vice versa. You know, it can happen. It's rare in my experience, and I do a lot of troubleshooting. And what's weird, the reason why you guys have me and Steve and some of the other guys, Steve's here because he's got so much experience over so many contractors in the paving side. That's why I wanted him up here, you know, and I got a little ability to do that. You know, so I'm like, come on, Brian, let Steve come, because he can talk about paving and he can talk about all the key players in the state, you know, whereas a producer just has a tendency to just talk about themselves. I kind of go cross-platform. I just happen to also get sucked into running 3 plants right now for a few years. But I get the weird problems. So I'm weird. Remember the observation speech I made earlier today? That's the only reason I'm standing here. I'm telling you, I'm not that smart. But they'll call me, well, we can't figure it out. Would you come look? So I get an inordinate number of weird problems. Weird problems are my norm, you know, when I'm out on the street. And this is something that you see, you can take this to the bank, okay? It's rare that we really get cross-contamination to feed bins, but we got to be thorough in this presentation. It can happen, and it's mostly from overfill in the bins or the bin walls are non-existent. And then, of course, we can have stockpile commingling, okay? Or my favorite is one truck driver just follows the other, and one guy's hauling, you know, 1/2-inch rock, and the other guy's hauling 3/8 rock. You know what I'm talking about? And it's like, well, that's where they're dumping. So the next thing you know, you've got 1/2-inch rock and 3/8 rock mixed together, and 19 mil and the 12.5, you know, that kind of thing. So inspection practices are what we just kind of talked about. Steve's going to come over and talk about this because inspection is a lot of times dictated by the owner agency, and you've got a QC plan. And Steve's real familiar with this, so we're going to let him tag team this part.
So I mentioned earlier in my presentation that the Florida DOT has this segregation spec, end-of-load segregation spec, and it's actually a good thing. It's good for management of and contractors because it holds your people to a standard out in the field that they're going to do their job. Because if you don't do this, it's going to cost you a lot of money. So it's actually a very good spec, and it kind of falls into inspection practices that you want to incorporate into your program. So if you don't have a segregation spec in Kentucky, feel free to look on Florida's website and pull theirs out and say, hey, we're going to do this. We're going to use density gauges to look for segregation. We're going to use infrared temperature guns. We're going to cut cores. We're going to watch these trucks. We're going to do this type of stuff. Put it on that checklist, you know, talk about it before we pay. Again, those 3 tools that I showed you earlier, pavement quality indicator, nuke gauge, infrared temperature gun. These things will all show segregation. Segregated material in the coarse part of it will not have density. I've seen cores as low as 79% density. That core that at the start of the presentation that I'm holding in my hand just had wormholes, I call them wormholes, or interconnected voids all in the core that water would just go straight through. So you have no density. It's just air in there. 79% density. That's why it comes apart so fast. You want me to keep going at the plant? So at the plant here, you want to follow the quality control specifications again. I'm sure that Kentucky has a nice set of specifications that make heavy requirements at the plant. checking incoming gradations of your stockpile, checking or having proper separation of your stockpiles so we don't get that co-mingling. Those types of things that quality control can help defeat or the cause of segregation. So loading operation at the plant. So we want to make sure we're loading those trucks right, correct? The slot, what do you call it? The slot. Batcher operation, we're going to check it daily. TJ mentioned that. We want to go up there and check it daily. All your transfer points and your slats. So drum mix plant, where it's coming out to the discharge chute, we're going to check that, make sure there's no buildup. Going to check our slats. Our slats, they can get built up as well. Make sure we don't have a dam on the slats. There it is, the drum mixer area buildup. Check that weekly. That's a good one. Find a lot of problems there. Batch plant, pug mill tips, and shanks. Check those weekly. If you're running a batch plant, you want to check those things versus a drum mix plant. Cold feed bins. We're going to look at those cold feed bins for the co-mingling, right? Wrong aggregate in the wrong bin. Or we might have them stacked too high and it's just falling over in there. It happens. Check our stockpiles. Should have good inspection prices for stockpiles, good separation in them. They're built correctly. They're maintained correctly. On a slope, we're getting all the water out, so nice and dry. Check our incoming aggregates. Florida has a specification. You check it every 1,000 tons or incoming every 1,000 tons. That's what we do at our place. If we have a problem, we check it more often. Or if we're getting a new source of aggregate, we might check them. Or something changed at the quarry that we kind of hear about, we'll check it more often. So those with the asterisk are the most common causes of the plant segregation problems up there. So drum mixer buildup, batch plant, pug mill tips, and your batcher. 80-20 rule, right? So prevention. So prevention at the road. So we need proper planning. Balance the paving operation and have sufficient amount of trucks. So that way we don't have to stop paver, right? It's a sore subject these days. Trucks are hard to find. Truck drivers are hard to find. Set a paver speed so that density can be achieved. So I've seen people pave at 85 feet a minute, 100 feet a minute, and they never got density because they're going down the road and they're going so fast, they're segregating the mix. It's crazy. Set your paver speed so that you can achieve density. It's going to help you. If you do happen to get a little bit of segregation out there, then if you get density on it, it's going to help you. It's going to make the road last. Assure trucks are clean and in good working order. Don't have buildup in those trucks. That can cause you some issues. Monitor the mix temperature. We don't want to get cold mix. Cold mix is, when it hits that screed, it's going to segregate. Monitor those mix temperature, 10 degrees, plus or minus, consistent. Load the paver hopper properly. So we back it up, get the bed going up, mix shifts, unlock the gate, flood the hopper. Don't want to trickle out of the truck into the hopper. It's going to segregate. Maintain that hopper 1/3 to 2/3 full at all times. Don't run the hopper empty. Keep a constant head of material on the auger and the auger ends full. All these are prevention. Avoid folding the wings when the slack conversions are exposed. I talked about that earlier. We don't want to fold that outside mix that's segregated, cold, directly on that conveyor. Put some mix in there, then fold the wings. Keep the paver moving at a steady speed. Probably said that 3 or 4 times. Minimal hot stops only. Everybody know what a hot stop is? So if I got to stop or run out of trucks, I want a hot stop. I want to stop that paver with plenty of mix in the auger and plenty of mix in the hopper. More the better. Asphalt in a mass maintains its temperature. So you can stop everything and sit there and wait till the trucks get going, or if we got a problem with the mat, whatever's going on, we got to stop that paver, hot stop. So an MTV or material transfer vehicle or shuttle buggy, whatever we're calling these days, is not required by all owners agencies. I know in Florida they don't require it, but it'll help your operation. If you can see to put one in, put it in the bid, make sure you get paid for it, it's going to help you with your texture issues. It's going to cut way down on the human error. And thorough quality control throughout the operation. So rely on your QC guys. Hopefully they've been trained right, and they're your extra eyes out there. Everybody's holding a shovel, they're holding a lute, they're running the paver, they're busy. Those quality control guys are out there to look at quality. You've got segregation, rely on them. So prevention back at the plant? You keep going?
I'd keep going. So this way, I get paid, but Steve does all the work, right? This is handy. This is what I said earlier. We're going to tell you what we told you and then tell you again, right? So, yeah, Steve, just go through these because I think we beat this to a pulp already.
So again, we're going to load the trucks properly. Make sure the batcher functions correctly. That's a key point. It's probably the fourth or fifth mention of the batchers. Batchers should fill completely regardless of production rate. So we want to make sure we fill that batcher up before we discharge it into the silo, right? Every time. We don't want to short it, have mix falling through it. Monitor the slack conveyor speed if equipped with a variable or VFD.
Which means you can slow it down.
Slow it down.
Okay, that'll keep material from discharging to the far end at the discharge point, or, but you don't want it to back over the tops of the slats either, because when it rolls over the back of the slats, if it's going too slow, number one, your amps are gonna go high, so you're probably not gonna do that because you're gonna get scared of your amps, but it also will keep that roll back. So most of our plants now are equipped with VFDs on our exhaust fans, our burner blowers, and the slack conveyor is one you want to look at. The big benefit from a quality standpoint is minimizing the opportunity for segregation on that piece of machinery. From a cost standpoint, you got two benefits. Number one, your kilowatt consumption goes down, okay? So remember, these things are designed to run at an excess speed for what the plant's designed at. So by cutting back the speed, you're cutting back your electricity usage, okay? And number two, chains and sprockets wear out not by the mix you run, but by the rotation. So if your sprockets wear out every 6 months, which is really when you need to look at them. Oh, sorry. I apologize. Really bad. So let me back up on that. Sorry, Brian. Slats and sprockets, which is very expensive repair at a plant, wear out based on rotational speed. So we talk in terms of tonnage, which is what we shouldn't talk of, but I've been in the business 40 years, we do that, right? You should check your sprockets every 250,000 tons. You should consider flipping them, really. You know what if 250,000 tons is 4 months of production for you or 6 months of production for you, what you really ought to say is you ought to look at your slats and sprockets every 6 months. Because if you run 100 ton an hour, they're going to wear out in 6 months. If you run 300 ton an hour, they're going to run out in 6 months. If you don't even run any ton an hour and you run them for 6 months, they're going to wear out. And it's huge. I mean, right now to rebuild a slack conveyor, punch a hole in 80 grand, okay? Just chains and sprockets, and slats are going to run you in excess of 50 grand. So you got a benefit here that you're protecting mixed quality and you're saving the company money. So these VFDs really need to be looked at a lot, and we'll be talking about that from an energy management standpoint. But they can also be the cause of segregation. So I'll just keep going since I'm here on plants. Monitor the pug milk condition if you're running a batch plant. Again, this is a key point, and a lot of us still run batch plants, so you lose a tip, you lose a shank, they wear out, and you lose the rotation. A way to check if you got a problem there, a little troubleshooting thing, if you think you suspect you've got a problem with your pug mill, is just drop a full batch, okay? Just drop a full batch and check one side of the batch from the other side of the batch in the truck. Test it. If they ain't the same, then you got a problem, okay? Big batch plants can't run small batches without segregating them. Hello. So we've had to set up rules like with guys that have 10,000 pound plants, like 5-ton plants, 6-ton plants, guy can't come in and get 1 ton or 2 ton. Because if you run it through the pug mill, 1 or 2 ton, if you go to a silo and you load it, you're fine. But if you load it out of the pug, it's not, you don't have enough depth of material in the plant to create a homogeneous mix. And you want to prove it to yourself? Go do it. Put 1 ton in, 2 tons in, 3 tons in, 4 tons in, 5 tons in, test the mix, left and right, left and right, left and right. Might take you a week to do the test, and you'll see it. We set up a brand new 10,000 pound plant in Guam, which is really a 4,000 pound market, 6,000 pound plant market, brand new plants. The only brand new standstill batch plants. The guys in Kentucky sold it to them. And we could not make a consistent DOT mix of less than 8,000 pound batch, 4 tons. 4 tons had to be run through that plant to make a homogeneous mix. And we worked on the tips, and it's a brand new plant, dude. And we worked on this plant night and day for several days to get it. We finally figured out what we need to do. So smart alecky me, we walk out of there, and I said, so you didn't buy a silo? Well, we're halfway around the world. I said, yeah, I think you want to buy a silo. So I sold somebody got a silo order out of that deal for $1.5 million. Okay, the only batch plant, the only asphalt plant on Guam. And who are the big customers? The Navy and the Air Force. And what do they have? A runway. So you're working with FAA mixes, P401 mixes, right, out of a batch plant, and the U.S. government's paying the ticket. So, we ended up with silo. Monitor your feed bins for crossing. So this is prevention. Again, monitor your feed bins and best practices for all stockpiles. I'm going to segue right here, and just for a moment, Steve's going to come up and say, what if you find it on your job? What are you going to do? Because I like him speaking from an owner agency standpoint. But here's the challenge here right now, and this is not on the agenda, okay? We come here and we learn the best practices of what to do. This program right here is like, well, when things go bad, what do you look for? Steve already talked about creating habits. I talked about the people who make consistent mix, what they do. He talked about paving, what they do. The challenge here is for us, and we're all managers. The paving foreman is a manager of that crew. The plant operator is a manager of that plant. The loader guy, the guy on the ground, the guy helping him load trucks, okay? QC people, we're all managers. The challenge is reducing these. We're on a program right now. I'm on a program right now, and I'm kind of on a rampage on this, of the 5 things you need to do your job successfully. So the loot guy, what are the 5 things? The screed guy, what are your 5 things? The loader guy, the guy running a paver, what are his 5 guys? What are his 5 things? My loader guys, feeding the plant, what are the 5 things you do? Always do those 5 things. You're making mix, what are the 5 things? Consistent temperature, don't jackrabbit the production rate. Producing steady runs. The 5 guys loading trucks, what do? Don't load below the cone lines, There's 5 things at every one of these positions we do. We have to ingrain those in, as managers, in those craftsmen's heads. And Steve said it earlier, and you probably missed it. The key that we've learned for managing people is that the people in the know, you either empower the QC people to enforce those best practices in the field, or you empower the plant foreman, the plant superintendent, your floater, or hire a guy as a quality management guy. And all he does is go from plant to plant and make sure, did you look at the batchers today? Did you do this? And did you do that? And just that constant pressure, circle back around and make sure this work is being done. If you manage the activities, you get positive results. from a management standpoint, how do we make sure that, guys, there's a right way to do things? You've heard me say this before because you invited me here a lot of times, and I can't shake it in my old age, and I'm old. I'm old. I've been in the business longer than probably any of you in the room now. What I can't shake is that there's a right way to do things and there's an easy way to do things. And 80% of the people that work for us go back to the easy way. And we have to be the ones that go, come on, come on, come on. You know, come on, let's do it right. You circle back around and make sure that people are doing what they need to do. And you don't have to be, if you got the bodies and you have the right spirit, you don't have to be a jerk about it. Now, we're going to go forward with this presentation because things are going to go wrong, and we're going to talk about the bullet points that are on this thing. But if we do certain activities, we won't get into trouble, okay? Or we'll reduce the likelihood that it happens, okay? But here, what we're talking about is, okay, you got segregation. How do I troubleshoot where the problem is? So let's just move forward with this. Steve? What to do if you find it on your project.
All right, so what do you do if you find it on your project? So transparency is always the best way. So if you're gonna notice, if you notice common causes of segregation occurring during the paving, you wanna notify the QC and the paving foreman immediately. Hey, we got a problem. Whoever sees it, we got a problem. People in charge out there on the job need to be informed. Notify the plant immediately. So, hey, we have segregation out here on the road. We're going to go through our steps. We're letting you know so you can start going through your steps. Have QC check areas behind the street and at truck exchanges for temperature and density. So let's get back there behind the screed, see if we got temperature there, and are we getting density? Maybe we can save this mix. If we get density, we can save this mix. That's the key. Remind QC to monitor and as required in the specification. Keep reminding them, keep monitoring, keep monitoring. So if you notice segregation on your project after the paving shift, so that was during the paving shift, so this is afterwards. We need to notify who we're working for. Go ahead and tell them. Tell your owner agency, whether it's DOT, Walmart, whoever you're paying for. Hey, we got some segregation. We're going to work through this and get it corrected for you because we know that the pavement's not going to last. We need to get our lane and station locations. And let me back that up. Get our lane and station locations or wherever it is so we got this recorded so we can talk to whoever we need to talk to about this segregation. So probably the biggest thing is to consider stopping the operations. That's a tough decision. But if we're having segregation issues and we've experienced firsthand and we didn't stop, and we're going to be paying for it. So it's a tough decision, but if you got a bad segregation problem and you can't put your finger on it or if it's coming from the plant, you need to stop that operation. I mean, you might have a milled hole out there that you need to send something out there or shorten it up or whatever. But if it's so bad that you can't get it corrected immediately, you should really consider just stopping paving for the night. Just don't do like we did, keep putting it down, putting it down, putting it down, and say, we'll worry about it tomorrow. It's not a good decision. Remember, chase it backwards because the cause will be immediately after the point that it does not exist. So if I start looking for what's causing it, I find a common cause, boom, batcher wasn't working correctly. There's my problem. Wherever that segregation stops is usually the problem. 100% of the time it's the problem. Refer to a handout we're going to give you or lay them up front for you to take or put it on Brian's website, I think. So it's a good source. Make copies of it and send it out to your people. So again, we're going through the bullet points.
Yeah.
This is, yeah. You want to go through it?
All right, so this was kind of at the paver, so we're working our way backwards now, okay? So failure to fold the wings, we talked about it. Failure to keep the ends of the cross screws full during paving, okay? Failure to keep depth of material high enough in the cross screw. I got to tell you this story. I got time, don't I, Brian? I'm famous for stories. It's 4:27, so we just lived through this about, I don't know, what was that, about 3 or 4 weeks ago. So it's a Saturday, we're paving, we're doing brand new subdivision, and I'm at home working. Steve's trying to coach baseball, I think, or something, or trying to have a little time with his team. And we got a problem out here. QC calls. They do exactly what we said here. They called the plant. They called me. They're like, we got a problem out here. So I'm like, damn. Here's Saturday's gone. So I'm sitting at home, and I'm like going, I got to go do this. So we don't know where it is, right? We're getting a report, and this is a big deal client. We're paving this huge new subdivision, right? And this is important. Now, it's a bottom lift, so that's good. But still, I'm like, I got to do the right job. There's a right way and an easy way, okay? So I'm like, well, I better go to the plant. So I drive over to the plant. It's only about 10 minutes away. I got a call from the field. They say they got segregation. Of course, you always blame the plant, right? But we're trying to develop this culture, which you heard Steve talk about, and I think it's with guys that are successful have this kind of culture. This is our observation, that it's like, maybe it's us, maybe it's you, we don't know, we got a problem. Problem ain't gonna go away by itself, okay? We gotta figure out what's going on. I go to the plant. So I'm getting a call. I think it's like you noticed anything? No, everything's cool. Do you guys walk the plant? Yeah, check the batchers today. 80%, 80-20 rule, batchers. And we have these kind of batchers that are my least favorite design in the industry. And I'm like, you checked the batchers? And they go, yeah. Well, they were loading out of silo 1. They only checked the batcher on silo 1. They had filled up the silo. They're over on silo 2. So I'm like, I don't trust my ground guy, right? To be honest. So I walk the top of the slack conveyor. I look at batcher number 2. The pin's shucked. One gate's working, the other one ain't. I'm madder than a hatter. So I go back down. How many loads you put in that silo? How much have you? No, we just went in that silo. I go, well, you didn't check all the batchers today? So now we got, how much mix you got? 85 tons in the air. I'm like, go to the other silo. It's Saturday. We got 3 silos. I said, we got 4 loads of bad mix. It's like, and I'm mad. I am very angry because we've been through this multiple times. In fact, we left about $18,000 out on the south side because of this, right? And we just carried on. Like Steve said, we got up in the morning and went, oh, crap. We'll just mill this up and do it again. It cost about $18,000. It happens to the best of us. So I'm like, I'm going to the paver. So I go out the paver, and I don't say anything. And they like it when the plant guy shows up because it's like we're taking them serious. But I know exactly what loads have got a batcher with 1 gate hanging, all right? And we're paving half-inch mix. So I'm thinking, man, this is going to get worse. Turned out those 4 loads weren't bad. But I just walked out there, said hi to the foreman, got up on the screed, talked to the guys, and I'm watching, and we got 8 trucks, and they had to back up a half a mile to get to the paver, or about a quarter mile, through this windy subdivision. Dump guy's not managing the trucks. Paver guy don't slow down. I'm watching him pave. He's got his paving speed, and I'm watching the augers. I'm watching the slack conveyors exposed. He ain't flipping his wings, okay? And I'm sending pictures to Steve. Steve and I were the only ones talking about this. Here's what we got. And he goes, oh, geez. And then I walked behind, and the guys are backscattering the rocks on the mat. And I'm like, guys, we know this is our own guys. This is the management challenge. They all know what needs to be done. I'm not saying anything to them. I'm not busting. I'm just watching. 4 loads come in. I watched this happen multiple times. Now, what was the real root cause of the problem? Backscattering the rock, and that's why they were seeing the texture issues, and they were exposing the paver. So it was a paver problem, really, and I got lucky. Those 4 loads didn't look bad. So I'm like, I'm going home now. But the real problem was they weren't managing the trucks. So the truck drivers are just managing themselves. And they don't even back a quarter mile up until they see the one guy drive away. And the paver guy ain't going to stop. And so we've got this, kind of load-to-load situation going. I knew we could sell the job, and I knew we were going to top it. Because what they do in Florida is they build the roads, and they put the curbs in, and then they build the houses. So they got something to drive on. And then we come back and top it later. And it wasn't so bad. I took pictures of the problem. But that's what happens. I promise you. I was just in California talking about this kind of stuff. Guess what? Tykert has this problem. Granite has it. We have this problem in California. We have this problem in Alaska where my daughter lives. We have this problem in Iowa. I have this problem in Kansas. This is our industry. If we can learn how to take the 5 things we need to do and create a culture where everybody does their own little part, we'll be a lot better for it. When things do go bad, we know where to look, and that's your handout, okay? So there's a real-life example. So during truck loading, load in multiple drops. Don't let the truck creep forward. Don't load below the cone line. When I got to Florida, there's a cone line on all the loadout screens. Got everybody together. I said, I'm warning you guys right now. You're going to report to me. If I see mix go below that cone line, you're fired. You're absolutely fired. I mean, that's it. In Oregon, a guy told me he solved his segregation problem when his operator broke his leg. I said, well, how does that connect? And I go up there and teach every year for like 10 years, like Packy. And he said, you know, I've been listening to you talk for 10 years. And he goes, I finally solved my problem when my operator broke his leg. I said, why is that? I told him and told him and told him, don't load below the cone line. And the foreman would call up and say, I need mix. And he'd load them out. I said, you know, you can wait 8 minutes to fill the cone back up. Guy breaks his leg, new operator comes in, my pay factor went up 2 points because he never loaded below the cone line. So this is something we know. So we go to the plant, we look, we got a problem, we walk up there, we see the cone being loaded out, boom, you probably found your problem. You look at your batcher, boom, you probably found your problem. Lose the cone on startup and some shut down. Some jurisdictions force you to do this. Kansas, you pave in Kansas, you're allowed to only store mix for 3 hours, and you lose the cone, and you lose the cone at the beginning of the job and the end of the job. And if you stop the plant, you lose it again, okay? They're very strict because they had a lot of segregation problems. Here's the thing. You're going to say, whoa, it was nice. He talked about Florida. He talked about Kansas. We're in Kentucky. Dude, think about making your own set of rules for your company. Think about making a set of rules that you know are the best practices that get you to success. Flex had me come talk a couple years ago in Ohio. We got Valley here, we got Eaton here. They work on both sides of the line. You know what the rules were back then? I don't know if they changed them. I hope they did. They wanted to talk about mix quality. You know how often they're required to sample aggregate the year I made that presentation in Ohio? Well, you got to check your stockpiles once a month. Dude, at 4,000 tons a day, you go through so much rock. One sample? No, what we do is every 1,000 tons, right? So if you know that you're going to sample, you have to sample to have mix quality, regardless of what the spec is, whatever the requirements are, think about, in my company, maybe I'm going to do it differently. So this is just something to think about. That's why we come to these meetings, to be exposed to new ideas and learn a couple things and maybe think outside the box. And quite frankly, that's why Brian has guys from the outside come in. Because if a guy from Kentucky made the same speech, you might not listen to it as well as a guy from out of town. And I got a guy coming. I've hired a guy to come down from Virginia to work with my guys the first week of March. And I told him, I'm not going to be there because I can tell them that, but if you tell them because they respect you, we'll have better success. So you're going to be on your own telling my guys, teaching my guys how to do that, even though I could do the job. Because when you go to work for a company, you're not as smart as if you didn't work there, right? The grass is always greener. The other guys are always smarter. So think about that going forward. So I'm just trying to tie this forward. At the batcher, we already talked about all these points. Holes in the gates, make sure the gates close all the way. Make sure the batch is large enough. Make sure the batches are fed in the middle because it can segregate right there. At the slats, we talked about 90-degree transfer points. Make sure they're tall enough, they're moving fast enough for the production rate, but they're not too fast. In the drum, mixing flights build up. build up, build up, build up. Feed the drum to the slat, should be at 90 degrees. Another good thing to do is to put, we'll get to clinkers in a minute, at the feed bins, cross-contamination, of course, making sure you put the right material in the bin stockpiles. It goes all the way back to the quarry. If the material is segregated coming in, if you're only checking your rock every 30 days, and you've got a problem with your rock, it's just going to manifest itself all the way to the mat. And that's why those best practices and knowing what's in your stockpile is really a key thing. So we have these best practices we did today. Production, paving. We introduced this idea, hey, no matter what you're required to do, think about what you're going to do in your own company. We know what activities bring results. So the question is, how are we going to create a culture where everybody wants to do those activities, right? When we do get into trouble, on a segregation standpoint, we know where to look. And if you follow this simple punch list and you work your way backwards, just like fixing your dryer, you will solve your problem. Last thing we want to talk about is clinkers. And we're right on time. What's a clinker? Some people, they call them dinosaur eggs. It's going to manifest itself into a warranty issue. What clinkers are, basically, is, where's my picture of a clinker? A dinosaur egg. It's usually going to be all fines and all asphalt. These are the chunks in the mixing area, or the mixing tips, or the slats that break off, because they're not going to continue to build up forever. They're eventually going to fall off of their own weight. Or, now that we're running higher percentage of recycle, and you superheat the rock to heat the wrap, when your wrap bin bridge is over, you can set your mix on fire, right? Because now you got 800, 900, 1,000. We have 1,100 degree stone inside our dryers at 40% recycle in Florida because we're running 4 to 5% moisture in our wrap. 1,100 degree rock will clean that mixing area out. And the slats, and you're shucking chunks to the paver. What I try to do is go into another silo, and it takes about 100 tons of mix, and they'll clear out whatever chunks are in there. So it's happening. It happens to us everywhere. Every plant will build up. So the key is keep an eye on that mixing area, keep an eye on that slat buildup, and clean it on a regular regimen. And, I've had to threaten loader guys that I'd fine them $100 every time they ran a wrap bin out of. Yeah, this is true. I mean, I'm big in $50 bill and $100 bills. And my best loader guy kept running the material out, running it out. And finally I said to him, Gary, I'm going to start charging you $100 every single time you run that bin out, because it causes a huge quality problem. It's not just an inconvenience. We got temperature spikes, temperature cold, chunks coming out of the plant. It's a problem. This is the world we actually live in, and this is stuff nobody wants to talk about. But we all deal with it every day. So keeping that wrap bin. Once I threatened him, he hasn't done it in 5 years. I go, this is serious stuff, and I'm just going to fine you. He doesn't make enough money to lose $200 or $300 a day, And these clinkers, these dinosaur eggs, it's a maintenance issue. It's also an operational issue. And Johnny Tucker, a friend of mine at Aztec, who used to work for Aztec, he's on his own now, and a lot of you guys know him, he gave me the hint. He said, you clean it when it's warm. And we figured out it's 50 minutes. So when you shut the plant off, about 50 minutes later, you go right in there with a chip and hammer, and that stuff will just come out slick as pie. And on a slat conveyor, you can just open the top and run the slats and knock the chunks right off the slat, put them in the middle silo, put them in a truck, and put them in a wrap bin. So a maintenance regimen is implied here, and, clinkers are going to be a segregation type issue. It's going to cause a problem, with the mat, because they're going to pop out, and that's going to become a warranty issue. So thanks, guys. I appreciate this. Questions? We're going to have the handouts down here at the front. If you want to pick one up, I'll put them on that middle table. You guys have any comments, questions? We appreciate coming. Really a lot, and I hope it at least got the juices going upstairs, you know, so that's a win, and I appreciate it very much. Thank you.